In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel.
Hello, everyone, and welcome to Saturday. Sorry about the late start. My name is Nathan, otherwise known as Old Man Builds, and we have Joe here today, and we're going to talk some crystals and some caves and some cool stuff. Joe, what's going on?
Hey, not too much, Nathan. Feels like it's been a long time, but it's only been since Wednesday.
Yeah.
That was an awesome cast you guys had last night on Mike's channel, the League of Incredible Inventors.
Yes.
And definitely some interesting conversations there. For sure.
Yeah.
Yeah. So, there was a couple things that I thought might be interesting to talk about today. And I know I had asked in the cast last night if there was anything anybody wanted to hear about. So a couple of those things I'm very interested in too, but I wanted to do a little bit more digging into those things so I could kind of talk about it a little bit more intelligently.
Okay.
But one thing that I had come across that I had heard of, didn't really know a lot about, and recently learned a little more about was called Vogel crystals, Vogel cut crystals. So there was this guy back in the 50s and 60s who worked as a botanist. Okay, and what he realized in working in botany was that the plants that he was working with were reacting to, his pruning. Okay, and every so often he would go into prune a certain branch, but then back off and choose not to prune it. And he realized that just the intent of him actually wanting to prune it was enough to affect the plant. Wow. Then went on to find that he would hook it up so he could track the electrical impulses through the plant, and realized that it knew the difference between if he intended on cutting it and actually went to go do it versus when, if, just as a baseline, he would pretend to go cut it with no intention to do so, and it would know the difference.
Really?
Super fascinating stuff.
That's so cool.
What he found very interesting was that he could actually remove a part of the plant, like a branch of it with a leaf, let's just say, and then he could actually take that branch and leaf away from the plant, and the plant would react with the same electrical signals as it would if it was still attached if he went and cut the leaf. Which was super fascinating. So he drew some type of comparison after thinking about it for a while, and realized that the intent, the feeling, the energy that a person gives off actually transmits, and could be received by certain certain plants, people, just the environment generally. And what he found was that it could be harnessed, made coherent, amplified, okay, and then projected through a quartz crystal, okay. And the quartz, what makes it a Vogel crystal as opposed to just a normal piece of quartz is that is the way that it's cut. So I forget off the top of my head exactly, but when you do the angle settings on it or something, it has to be derived of 51 degrees or something like that. So it's got to be 51, 51, 51. And when you add those measurements together, those are the angles that the pyramids were ultimately built off of, the cap of the pyramids. Yep, so those are Vogel crystals. So the way that it supposedly works is you hold the bigger side because it's tapered. So that taper is actually cut into the crystal.
Okay.
You hold the larger side, that picks up on your energy and ultimately projects it out of the other terminated tip.
Okay.
So these types of crystals, they have to be a couple of, like, there's like some criteria of what makes it a Vogel crystal, because he found all of these particular factors to actually be important for at least this intent. Now, if you were using for other intents, possibly there's some leniency here, but he found that it has to be natural quartz. He said that lab-grown quartz doesn't have the same properties for this case. When you cut it, you have to cut it to a double termination. There has to be a specific taper involved in it with one side larger than the other. And that's what assists with the transmission and amplification and projection of it.
Okay.
And here's where it goes a mildly woo. All right, mild woo here. It has to be cut by hand, not machine. Could be cut on a machine, but it has to be held in someone's hand. Okay.
Okay.
And the person that's cutting it has to have good intention when they're cutting it.
Wow.
Now, because think about how that goes with the plant. The plant knew the intention, and I guess he's supposing that the crystal does too.
So you think there's a symbiotic relationship going on?
I mean, we are one with our environment, whether, it's part of it or not. I don't know what the crystal would gain, so to speak, out of that relationship, or what the effect would necessarily be if the person didn't have good intent. They're like, I'm gonna cut this crystal for an evil magic wand because, like, I'm a sorcerer or something. Like, I don't know what people are thinking. Like, I have no idea, Nathan. But yeah, that's what the guy said, is that it had to be cut with good intent. And as far as it being symbiotic, I don't know. What do you think? I mean, how would you figure that might be a symbiotic relationship?
Well, it has to do with the quartz, and it has to do with the crystalline structure that's actually in part of our brain. So we communicate with it without knowing, but we don't realize it because we haven't tuned ourselves into it. That's what I think. So the relationship is more in the frequencies that are going on maybe behind the scenes that we're really not on a level to understand yet.
Yeah, that's possible. I mean, there's I see how you're angling it now, and it makes a lot more sense to me that way. I think that there's an interactive relationship, more than a symbiotic relationship in that case.
Okay.
Your brain does have magnetite in it. Magnetite's unique for a couple of reasons. One reason being that it's the only naturally magnetic substance that just comes out of the earth that way. But one other thing about magnetite is that it's also a silica oxide, derivative. So, I mean, it realistically shares most of its crystal structure with quartz. So that in itself could be enough to, suppose some kind of, resonance and things of that nature between the two materials just on their own, without there being power put into it, whether it's through your hand or external. But the interest in it didn't just stop there. I mean, he ran a whole bunch of experiments with it where he exposed that crystal to water.
Okay.
And what he found was that when the crystal was activated and was in the presence of water flowing around it, that even just a couple of seconds in its immediate field, that it would instill into the water detectable effects in the UV spectrum that weren't present there prior to or after. And what was even more interesting is this wasn't just a temporary effect. This is something where you could actually then take that water, you could put it off to the side for several months, do the same test on it again, and you know, there was still a change in the UV spectrum of the water under that condition. Which, I mean, if you think about it, you know, and you want to tie it to the, you know, stuff that people do. I mean, think about holy water at church, you know, and then that ties right into Masaru Emoto's research that he had done for a number of years, which more or less said the same thing. He said, if you're kind and, you know, loving and nice and you know, have a high vibrational field yourself, and you express that in the presence of water, that the water has a memory. And he ran similar tests in a way, just differently, where he froze the water and then put the water under a microscope to inspect the crystal structure of the frozen water. And what he found time and time again was any sort of positivity that was in the equation led to beautiful crystal structures. However, any sort of dissonance whatsoever, any sort of negative energy, if you said even negative words, even if you said it in a positive fashion, you know, you say the word hate and you say it in a positive fashion, just the word hate was enough to create total dissonance in the crystal structure of the frozen water. And it would hold. So if you were kind to water and you let it sit and then you put it in the freezer, it would actually yield a better, you know, better, more beautiful crystal structure than water that was mistreated, so to speak.
So there's positive energy in the structure as it's being built. So that's interesting. So if you went in there and say you did some sounds, you did some the throat thing you were talking about last time, or you went in there and you treated it like a cathedral or something like that, into like a crystal cave, do you think it would grow or put off thoughts like that to you?
I don't know about putting off thoughts like that to you, but I think that the implication is more if you ingest water, you know, that has had positive energy put into it, or if it absorbs into your skin, or just the fact that your whole body is made of what, like 70 some odd % water in itself, you know, the implications of, you know, that effect being that we are so much water, you know, all makes sense. Plants are even more so water than we are. And then that starts to make a little bit more sense too. And there's the correlation. I mean, immediately where my mind went the first time I had heard this, which was like a long time ago, was cymatics. You know, you could immediately see the redistribution of the particles and how they want to arrange based on the sounds and frequencies that are put through it. But what's interesting is that because it holds the effect, it could arrange like cymatics, perhaps, but it's got a memory. You know, water has a memory. Now, how to access that memory in some sort of tangible and meaningful way for us, other than knowing that the phenomena exist, I don't, you know, I don't believe that to be the case. But in Bentov's book that I always reference, you know, Chasing the Wild Pendulum, he references an old thought experiment. And that thought experiment was that if you were to, you know, suppose you had a pebble and you drop it into a lake or a pool of water, and as soon as the pebble hits, even though it's still sinking to the bottom, you were to freeze the surface of the water, okay, instantly. If you were to take a coherent light source at that point, like a laser, and you were to project the laser onto that surface, it would actually create a hologram of the whole entire incident, even though the rock is at the bottom and has already fallen.
Hmm.
You know, you would actually see the rock falling in the water.
So here's an interesting thought. Okay. Tammy brings up resonances. So our body resonates. If you resonate a crystal in water and the water picks up the memory of the resonance, it would also bring into why holding it, because your water would excrete water as sweat. So you'd transfer the resonance through that from the crystal to your body, or body to the crystal. So then it would pick up the resonance. So if it's good thoughts, there's a certain resonance pattern that builds. When there's bad thoughts, there's a certain pattern that builds. So that crystal would not, I don't know if it would take it on, but it would definitely amplify whatever that was going on. And then if the water was memory, it would then have a transference.
Exactly how, you know, that works. And you know, any good sample of quartz will do that. And many other crystals too, but quartz is always just a really prime example because it's basically, as we've discussed so many times, it's structurally ideal. It's made in resonance and so on with the earth itself and all that comes of it, you know. So that is naturally going to be a pretty universal substrate as far as, like, you know, any sort of transmission is concerned, you know.
But it also has bigger implications for the earth itself, because these things grow in natural formation in caves. It kind of has a resonance of its own. So however the earth is doing, we're getting that resonance from those crystals in that cave.
Yeah, for sure. You know, that's definitely the case. And you know, it's actually really cool because, you know, they were actually saying that when you as a human transmit through one of these Vogel crystals, it's super low frequency to the point where it might even be scalar. I don't think that they were able to measure the wavelength. It was so long that comes out of the tip of that thing. That means it's unstoppable. That means that it's almost impossible to interfere with. That means that once it's out there, you know, and that it could be sent over long distance, even without an objective high power source behind it, you know. And obviously different people have different frequencies, different levels of energy that they can concentrate and, you know, use. And, you know, obviously if you're practiced in that, like, you know, there's some of these monks and so on, they practice Tai Chi and things of that nature. You know, that chi energy, it will transmit right out of your body through this crystal and through our, you know, through our atmosphere. And, you know, again, what's the implication of that? I mean, I think that any person would be susceptible to intercepting that that resonance potentially.
Well, I like water as a medium because when rainwater you get fluoride. Fluoride activates the crystal in quartz. When you have it inside granite under pressure, it'll actually take on a conductivity. So you have electricity that goes in it, which is a whole interesting fact in itself. But what I like about quartz too is it's a timing crystal. So if you tap it, it taps back, and it does it in precise timing. So as the earth itself shakes a little bit and you get resonance through the shaking in those chambers, it's going to tap it back. So whatever the frequency is going through the earth, it's going to resonate inside that chamber with that crystal. That's what I think so cool about this. There's a little more. So there's a little more to it. So when you say it goes in low hertz, it makes perfect sense because the earth itself resonates in the low hertz. So it kind of tells you a little bit more about, we produce energy on earth and we don't really realize how it's going on, but we start to see signs of it. We start to see that maybe there is a little more crystalline structure involved in this because of the actual frequency and the resonance rate that we're getting out of the earth. That I find very interesting.
Absolutely is. I think that a lot of like the forces that we experience energy as, that are always discussed, whether it be forms of magnetism, different electrical charges or plasmas, um, when it's manifest in that regard and not just potential, I kind of believe that there's more dimensionality to it. We'll just call it it for the simple purpose, right? There's more dimensionality to it than we necessarily suppose. And I think that the mind obviously usually goes to toroidal, knowing that that's the constant motion that we observe time and time again with these phenomena. Um, but what's not often discussed is that, you know, not all Tauruses are the same. You know, when you're talking about a three-dimensional Taurus, you're talking about a donut. And if you want to think about that, you think about it like the coils that you build, where it's literally a three-dimensional object that appears as the shape of a donut.
Yeah.
Whereas an actual Taurus, like in fourth dimensional space, when you're talking about time space, it's not a donut. It's just a good way to think about it. It's really a sphere. So it's a sphere with an internal structure that isn't really inside of it, because it's simultaneously inside of it and outside of it at the same time, pulling its inside out and inside in, which is what we experience and what we discuss when we talk about the field patterns. So it's just unique to think, because a torus is in fact just a ring, but it's also really just a globe that's turning in on itself too in the upper dimensional mindset. Now, when you start expanding that dimensional mindset beyond just the fourth dimension, it starts to get very weird very fast, like we saw the other day when I was on.
Well, so. I find it ironic that they have crystal dealing with time, and we always talk about the earth time dilation, stuff like that. There's moments in time, and then we start to hear stories. Just a man appears out of nowhere in a suit back 300 years prior to when the suit was even available. Okay, we start to hear different stories like that. We start to hear about Roman soldiers going through somebody's basement, but they're in ghost form. They're old. There's a moment in time. I think the crystal has a lot more to do with this than we give it credit for. I think there's that memory there that you talk about, but it also shows that there's a relevance in the time. And I think it's ironic that we use quartz and watches just as time. So it's just a whole parallel there, that even if it's just a mental sense, it's still like a mind trip to even think about.
It sort of is. And I've kind of thought about the implications of that before, as far as like trying to, as weird as this might sound, but like trying to understand the perspective time, the time perspective of a crystal, as opposed to, maybe a human being right outside of its environment, like I would experience time. It's my theory that the more matter like something is, and the further it falls on the more matter like as opposed to more energy like scale, the less time actually affects it. Okay, now the more energy potential in a certain kind of matter, it's my opinion that is more susceptible to time and less susceptible to space than more depleted, elements and materials. So it's just interesting under that mindset, where you think of quartz, which, like I said, its formation is in some form of coherence with its environment at resonance, and just possibly the universe as a whole. Now, whether or not quartz is as significant on another planet, I think that's probably a topic for another day, because what's defining its environment of creation, and it's on Earth, so I think that we'll not go there. But supposing that it's Earth, that is the influence that it's in tune with, and the fact that it's a piezoelectric, making it a more energy-like form of matter, that time would actually be more significant to it than other lesser forms of matter. That's where I'm going with that. When you start talking about simpler forms of energy all the way up the scale, the less space matters, right? I've said that. So the less space matters. And well, that makes sense. Space matters less than, less to a wave with no frequency, with no transverse frequency, or a low transverse frequency, because it'll just travel indefinitely through that space, and not be impeded by it. So the whole entire thing kind of makes sense. If it's more energetic, the more time affects it, but less that space affects it, and vice versa. And as far as matter's concerned, quartz crystal is very high on that energy scale for something that's solid and doesn't ignite. That's what's interesting about its piezo effects, because it's not flammable. Usually energy rich matter is generally some form of volatility. The structure of the quartz crystal, actually has that energy contained in a stable manner.
So I hold on before we go any further. Something just hit me, and I want to say this. What if quartz? You say there's a correlation between the energy put in, right?
Mm-hmm.
What if there's a correlation in memory? So we store things and we don't realize crystal may store them as well. So we're talking about time and crystal and energy. What if when we see ghosts like that, like of old soldiers and stuff, it's quartz being resonated again, and it's showing that memory? Now, it may affect each person as they go in there because of the structure around them. They don't realize what's around them. So they may be in some structure that resonates at that frequency, and as it does, the quartz projects the memory. It's the way of the earth telling time. It's the way of the earth memorizing what happened. It's all of it happening now and then and now again.
No, I don't necessarily disagree with that at all. I think that's quite possible. I firmly believe, and I'll almost go out on a limb and say that I know definitively that quartz is, has the total ability to store information from its environment within itself. How and what conditions that can manifest and be extracted under that, I haven't really wrapped my head around. With the Roman soldiers, what I found to be interesting about that particular story was, I don't know that was necessarily a crystal effect, although it was kind of a cave that they underground, that the guy broke through his basement, and there was that phenomena that was observed multiple times. I think that might have something more to do with the toroidal movements that we were discussing earlier, where if you think about the movement of a torus as a function of time, where the inside pulling out and it, so on and so forth, the inside pulling out and the inside outside pulling in to it is in fact the local motion of time. You're going to have a situation in certain environments where not only is it stored, the event in the environment, but also that if since it's kind of folding in, there's there's events that could be similar, similar type of environmental events where like the time is folding on top of itself, and at those points where current time is overlapping the history time, of what had occurred there previously, there was large amounts of energy discharge during that time. Maybe potentially that's cause of manifest in that particular situation. I think that seems to be, I don't know that I explained that well at all, but I time folding on top of itself and then manifesting sometime in the future because there was an energy dump in the past. That's more or less what I'm saying.
I think it's not so much the crystal at that point, it's the resonances.
Yeah.
See, the crystal would be the memory, but the resonance is the chamber. So when we remember your rock, we were talking about chambers inside there and resonances, and there was crystal in there, and they would affect them differently and create fields out of it because of the way it would go. And that's an energy source people don't really realize is something that you have to take into account for everything. Resonances can happen in the earth everywhere, and every single structure in a cave would have them. But how they correlate with other things, and all it has to be is A has to be matched to B in resonance, and then there's an exchange. So the projection is something that's absolutely unbelievable, and I don't know if it's a physical thing or if it's a mental projection. You know what I mean? It could be they're seeing it in their head and not actually it being there. So it's just fascinating to me when people start talking about this, because I don't think the true potential has been reached yet. And people have to correlate the resonance in everything. And I know that when you go on data transmission, it seems simple to us, push the button on your phone, it transmits. What? Why? Because it's resonating that to the actual fractal that goes on to resonate with the tower, and then we get it back as a signal. So you just call that transmission. We understand that, but what if crystal just transmitted differently? What if it just transmitted in resonance instead of fractals? And then maybe it's a fractal in the resonance. I don't know. I'm just saying that there's a lot more to ponder in this whole thought process.
Oh, yeah, no, it's there's so much to think about. For what it's worth, I mean, what you just said was the whole entire basis of why I said about that Bearden 0 point device that I was talking about.
Yeah.
It was all about the transmission of the potential frequency. What else could do that?
Yeah.
Like that's the thing. I mean, and in a fashion where it could actually be directed and consolidated. That was the only thing I could think of that would actually, do that. And the more I thought about that system, interestingly enough, was I felt like you needed to have something outside of the conductor that all that would be taking place in, which leads down just another rabbit hole of stuff to do with crystals, because I feel like the ideal medium to be surrounding like a piece of steel or iron, let's just say, to capture that energy is actually diamond in that circumstance. That's an expensive experiment to do, but if anybody ever had a wedding or engagement ring thrown at them or something and they don't have anything to do with it, let me know.
So interesting. I saw somebody do an experiment once with diamond, just as a caveat to the side. He put pure oxygen in there in a container with the diamond, and the diamond turned to dust. So the hardest substance in the world could be taken down by pure oxygen. One of the neatest experiments I've ever seen in my life, man. Costly to him, but I was glad to be able to see it. So
did it just make carbon monoxide or carbon dioxide or both? I mean, that's
it broke down all the oxygen inside the crystalline form. It created something in there that it wanted to bond to besides what it was already bonded to. And there was heat involved, okay, but heat in diamonds doesn't really bother them. It's the pure oxygen, that the combination of it. So we always look at things dissolve in nature, and we don't know how, but they seem to do it. And I think that's one of the rare times you get to actually see the science behind it.
What's interesting about that is the just the whole idea that I was talking about matter energy potential. And oxygen is extremely high. And although I don't know this scientifically, I'm going to propose that based on its nature of formation and so on, that diamond is extraordinarily low as far as energy potential is concerned. So it would take a lot less concentrative energy for it to break down under that circumstance. But the thing is, it appears that it can't be pure energy because you can't burn the things. You hit it with plasma, nothing happens. So, you need high energy matter like oxygen to oxidize it, to bridge the gap, to bring it back to a state where it could be decomposed. But it's probably one of the most difficult to decompose, things out there. Yeah. By the way, before we get too far off, I just want to throw it out there. I see Library of the Untold Joey in the chat. I showed the guys your book the other day because I'm about halfway done with it now. I'm digging the book, by the way. And let me tell you something. I just read the back blurb on all the things that you considered when writing the book, and it set off like a 2.5 hour long discussion after that. That was the other day. When I was on with Victor and Gerald.
Yeah.
So that was really cool.
Definitely was an interesting conversation. Every time Victor's involved, man, you get a mathematical formula that just blows your mind. It's cool.
Yeah, it's funny for a guy that stumbled upon the math in a dream back in '86. He's definitely a free spirit who knows a whole lot. And I love that about him. He's a good guy.
Yeah, definitely. So let's get back to the crystals and stuff like that, because I just love these things, man. I love doing experiments on them. So, some of the energy that you put in there doesn't have to be tapping it physically. All we have to do is create a pulsed field to tap it. So to actually turn it on, all you need is a little piezoelectric disc. It just has to have a strong enough pulse wave. You can also do it with water hammer. I see a lot of people in the comments talking about the pyramids and how they work and things like that. I mean, you have to realize when you're talking about quartz, when you start hitting water against the wall, it's a massive pulse wave. And a massive pulse wave is just as good as tapping the quartz. And it's a chain reaction that happens in it because you hit it, one goes off, the next one goes off, the next one goes off. And before you know, you got a resonance in the structure. And then it has a chain reaction because there's nothing stopping it at that point. So it'll continue to go until it goes to the whole thing. And then it'll do it again when it's hit again. And the field will grow every time until it encompasses the whole thing and reaches saturation.
Yeah, that's a really good point. If you have you're saying pyramid, so let's go with that. If your pyramid is tuned and everything in your pyramid's tuned to the proper angles and dimensions and so on, right? Anything that creates that, jarring initial resonance, it'll go crazy. You'll have sympathetic resonance. You'll have it reverberating all along the entire thing with nowhere to go. I could only assume that would, and then on top of that, now you're putting pressure on granite that's piezoelectric filled quartz granite, and now all of a sudden you have a chart. Obviously there's a lot to that as far as, the specific dynamics of what the particular result would be. I think that obviously would be power generation to me. But what I couldn't imagine and what I'd love to fathom is what it would be like to be at the door of the entrance to the chamber when that happens. You know what I mean? Like, and like, I don't know that you could survive it. Like, I don't know. Like, the pressure might simply be so great that you cannot survive it.
You'd have to be deaf or something broken in your ears, because it'd go right in there and start resonating everything. So
yeah, I could imagine that it's just a massive pressure wave that would, you know, come out.
So what I find interesting about it is they covered this thing in limestone, white limestone, right? And then they had this stuff going on in there. So the question is, and somebody said it in here, it'd be bright orange. So if you have this thing resonating in there and you have this quartz putting off light, which we know quartz does put off light when you hit them together, you get this light that comes out of it, and then an uncontrolled resonance in it would probably put off a ton of light. But then it backlights the limestone, so the limestone would be white. So they always picture the pyramids as some kind of a white structure with a gold top. And I wonder if that was really, back in the day, truly just a beautiful, brilliant white, glow. Because I know I take filament PLA for my printer and I put it in there and I put high voltage next to it, and it puts energy into it and allows it to glow. The same way light does outside. It'll put it in the same energy and allow that stuff to glow. I wonder if the actual energy was high enough to get through the limestone and create a glow in it, or a glow behind it where it would like peek through. It'd be an interesting thing to see.
It would be. It would be. I mean, one thing that came up in the chat just a second ago, Daniel Foster said it was about chrysoprase and Atlantis. I'd like to know more about that correlation personally. I mean, I have a couple of pieces of beautiful chrysoprase, and that in itself have unique properties because it's it's chalcedony, so it's like microcrystalline quartz.
Okay.
But it gets a green color from ionization of nickel and copper. I'm pretty sure it's nickel and copper. So it's really, really, chromium and copper, I believe it is. Regardless, it has this crazy green color. I'd love to know, the connection between that and Atlantis, supposedly. It's interesting. I've never heard that, so.
Well, that'd be interesting. I'd like to see that as well.
Yeah. Yeah, so Daniel, if you just drop it in the chat, I'll make a note of it, and that's something I definitely want to look into. And if something comes up on it, we could talk about it too.
Yeah, you think about it. We're just learning things about our civilization that they knew a long time ago. Mm-hmm. They had this stuff down. They knew about resonances and everything else. And I don't know that it was everybody, or there was just an advanced society that knew it. So there's kind of a question. They always said that the priest or high priest, whatever, would hide how they did everything from the people. So I always wonder if there was something more to it. If there was an advanced civilization that knew about all this stuff, they knew how to draw water out of the ground and turn the desert into a lush place for growth and things like that. That always interests me when you talk about the pyramid, because you always see it in the desert, but we know that it was green at one time. So how do you always correlate the two? Is it simply just positioning in the earth where the poles are, or is it something more? Did they bring it to the surface?
You have a good point there. I mean, I don't know so much that it's the positioning of the poles necessarily as much. I mean, I think that them bringing it to the surface is more probable. I mean, probably just as likely as that would just be the geology in the area, and how the rivers are flowing in the area and how big they are and the expanses of that, and what the outflow goes. Because I mean, one thing we know is that there was a lot of irrigation and things that they depended on. I mean, it really doesn't take much other than a drought for several years, which is recorded through history, as Egypt narrowly surviving things just like that, only for it to ultimately disappear off the face of the earth without real. I mean, I don't really think that that's one thing that I've come across all too much in my research was the downfall of Egypt. You could read about the downfall of Rome all day.
Yeah.
You could read about kind of like the Romification of Greece all day, but you'll never really hear all too much about the decline and, that dissolving of the Egyptian, Egyptians.
I think a part of that history is basically because it was a woman, or say an emperor. I don't know if they called the Egyptian, what they called her,
a pharaoh. Yeah,
pharaoh. There you go, pharaoh. So, if I'm not mistaken, what was the name of the pharaoh? Cleopatra. Yeah. So that was the downfall when the Roman came in there, and
she got with Mark Antony and Caesar and stuff, and then that was the end of it right there.
Yeah, I mean, that's basically what they're saying. It was just like, well, they did that, and then the next general came in and said, no, you're all done, killed everybody, and then they took it over, and it was basically done.
Remember that in November, folks.
What I want to know, yeah, that's funny. I saw that today. Anyway, what I want to know is basically the downfall of Atlantis and the society that was there. I think that big desert hasn't been uncovered yet. And once they peel back all that dirt and all that sand, they're going to find something extraordinary under there. There's a whole civilization stuck in time under that thing. And I think there's more to it than what we think it is.
You're talking about that big ring in Africa?
Well, the
northwestern Africa?
Yeah, they talk about the big ring, but I think Atlantis was more than that. I think it was it was more, they had the pillars there. They also had civilization on that side of it. There was Atlantis. There was all the things around it were more of it. You know what I mean? I don't think it was just one city. It was a whole entire country that was going on there, bigger than that. And it expanded.
I've heard it told that in the time of Atlantis, the world was a connected place, and that the civilization of Atlantis was not just one place at all. It was connected cities that kind of had almost like, they described it as like a passport system almost, where they, where you could come and go and not really fear, oh, well, I'm going into this territory. This is the olden days, where if you're an outsider, not from our small group of people that took over this land from whoever else, then you don't belong here and you're gone, or unless if you're here without a proper trade cause or something like that. That I had heard something to that effect at one time, so it definitely, if, like, I would say definitely expanded beyond just whatever it is. But if, there was obviously Plato had, talked about it and described it. And, in his description of it, it seems to be fairly, like, at least as far as the city of Atlantis is concerned, if you want to call it that, or nation of Atlantis, like, it seems to be describing that anomaly in Africa. As far as I mean, where else? It could be underwater. They said it went underwater, but that doesn't mean it still is.
Well, it might have been taken over by water, but the land still exists. That's very much could be true. Tsunami, stuff like that. Or when you start playing with resonances in the earth and you start bringing up water from the earth because you're looking to bring up natural water from the earth, you may be dooming your society in ways you didn't realize yet, because you're not bringing it up a little bit, because there's a massive amount of water in rock inside of our earth. You can see it any time that you take a piece of granite, simple piece of granite, set the edge of it into the water, and it'll work like a wick. It'll just pull all the water into that piece of granite without a problem. So that's how the rock and the earth works. It's filled with water like that. And there's 10 times the ocean in that rock than there is on the surface of our planet. So watch when you start playing with things like that, because it may be a very dangerous thing to do.
Yeah, I mean, there's truth in that. I mean, granitic bedrock in itself is highly porous, and there there could definitely be, well, in terms of like the rock side of things, and not that granite is a dolomite, but it has certain consistent characteristics with dolomite type materials. What dolomite is it's basically a mineral composition that also has other secondary mineral compositions throughout it, while maintaining its crystal structure. So, you could have multiple types of crystals, multiple types of mineral formations, all formed within a dolomitic like mass. And what's interesting about that is, if you could figure out, and they don't know how, they've been trying to figure out how to grow things like dolomite,
Okay.
but they haven't really been able to figure it out yet. But it's significant in the sense that you can put technically, if you get the base of the dolomite, you could also grow whatever you want in the dolomite to actually have different properties entirely.
Really?
Yeah.
That'd be interesting.
Yeah, exactly. Like, right. And that's what they're saying too. They're like, if we could figure this one out, this one's good, because it's sort of like having a fully formed crystalline solid, like doped ceramic. If you want to kind of, run a parallel as to something you could do in your kitchen with a wooden spoon and a bowl.
Yeah.
Just like stirring up the clay, throw a little magnesium in,
throw it in the microwave and we're good. That'd be so cool. You know what I love? Man, they always talk about it like our planet's more like Swiss cheese than we think. It's got holes and caverns and everything everywhere. We always talk about water tables, things like that, but it's absolutely true. So as one cavern breaks down, part of the earth sinks. Well, that also means that the way water works, some other part came up. So I always find that very fascinating when they start talking about that, because it really reshapes our earth. They always talk about this stuff coming in on each other, right? So you have this area right here and the earth folds in on it, right? That's what they keep telling us. Yet I have never, ever seen the proof of that. What I have seen is things that actually go down and collapse into a cavern, and then things build up when lava get under them. And you know what I mean? And they start exploding and growing new rock. So we see those processes all the time. I never see something folding in on each other. I don't see land masses moving a whole lot. I mean, they talk about all this stuff that sounds fantastic, but when you really look at it, it's just things implode and things explode, and that's the way it works. And things grow, and then we get magnetic frequencies when we get the lava flowing through the earth. We also get water that transmits energy everywhere. So it's kind of an easier tie-in to say, we see it, this is what's happening, versus let's put on our tinfoil hat and let's listen to these people start telling me about something that they can't even find when we got submarines that, reach the bottom of oceans. I mean, for God's sake, I think we'd see it by now.
First of all, it makes sense that the earth is just filled with tremendous voids and caverns and caves and understructure in the first place, because just based on the current models, anytime you have that type of tectonic movement, but then you also have fault lines within those plates that are moving and against each other, and then you also have a mantle which is not doing the same thing but is somewhat attached to the crust, because again, there's no definite barrier line there where this is molten and this is solid. There's molten and solid going on simultaneously in certain zones where, like, there's a locking effect between that, is where I'm going.
Okay.
Think about honey on a spoon. You know, if honey's on a spoon, it's stuck to the damn spoon. Just because you take your finger, you can't wipe all the honey off. It's, you know, and it's not like rubbing your finger against the spoon. It's not a fluid difference, you know. So because there's gradient of that, now you have those forces working and torquing against each other too, you know. So anytime you have all this movement and all these variables, you're going to have ripping and tearing, you know. And since, you know, even if the crust is, you know, 80% solid, say, okay, just say, that means that at any given time, 20% of it's void. It's probably more than that.
Yeah.
But every time that a void gets closed, it's got to go somewhere. And if it doesn't go up into a new mountain, it's tearing a new hole. And every time, you know, a part of a fault line gets shoved under another, it's just, again, cramping that system, closing a void, tearing another. It's just continuous. With water in that system, if you think about it, that's a stabilizing factor.
Yeah.
You know, especially if all of the mineral composite there is also more or less saturated in water. You know, it's not like above water where that would make the mineral heavier per se. That would bring it closer to the volume of the water that's surrounding it, meaning that it wouldn't have the same tendency to want to like collapse. Like it wouldn't require the same structural integrity, so to speak, as it would on the surface under regular atmospheric pressure, being a freestanding void. So if it's closer to the surface, not filled with water, it may well collapse. But down there where it's filled with water and it's all equalized out, it'll stand forever. You know.
Yeah. Well, we were talking real quick. I saw it in the chat. I just want to bring this up. Earthquakes. So what happens when you resonate one chamber and then the next chamber resonates? It's the same exact value. Then the next one, what you get is basically a fault line. You have an area that's susceptible to those resonances. So every once in a while, you get an offbeat resonance, and then you get an earthquake in the middle of nowhere. When you start playing with resonances on your planet and bouncing things off the ionosphere, you start getting earthquakes where you didn't expect them because that chamber has not been active in a long time. So as we see certain things go on, we know that all the governments are playing with this stuff, but now we're starting to see after effects. So, and I don't even think they realize they're doing it. And because they just don't understand what it is that's going on. And I could tell you by the science that's going on out there that I always see, they have no idea. They have no idea how it works. And they keep playing with stuff and it keeps causing, you know, certain things to happen. So I think that's one of the things we should watch out with earthquakes, is because when you start creating unwanted residences in certain places, you start having bad things happen. Now, good things happen if certain caves are resonated. You know, you always talk about the prophets and stuff like that in Greece, and they had caves like that, and there were special ones that they go in, and they, you know, different rituals, stuff like that, healing stuff, which I don't want to go into, but they always talked about something like that, where they can go in there and felt better or something like that. You know what I mean? Just good vibes like you were talking about earlier. But I think there's more to that than what people really think.
Yeah. You know what we could use instead of that word? We could just use wellness, like all the clinics that insurance doesn't pay for. You
gotcha.
Right?
I'll go with that.
How they get around it?
Yeah. No, I'll go with that.
It's a wellness center.
Yeah.
What you just said, actually, like it immediately brought me to something that not about the purposeful experimentation of it, but just the effect, the fault lines, and the fact that we were talking about quartz. I was bringing something up in the chat. I think it was yesterday, but I never really elaborated on it. I read this entire article that was done on vein quartz in fault lines. Okay. Now, vein quartz in fault lines is almost always under pressure and always under charge.
Yeah.
When there's an earthquake that even if it's only small, even if the fault line doesn't move all that much, it's just enough to cause some cracks that allow, highly saturated brine water, more or less, up through the cracks. Now, because the quartz is under constant charge, what it'll accumulate in those cracks almost always is gold because of the charge, because the quartz is in resonance with gold. Okay, so that charge at that resonance leads to gold accumulation in those void areas, where otherwise it probably would have just been another quartz deposit, or it just would have because the quartz in solution is only a very small amount, but you start pulling all the quartz to accumulate in these tiny void areas in contact with the quartz, and that's exactly what you have. And they pull huge gold nuggets out of quartz veins. In fact, that's why they mine a lot of quartz veins, is exactly for that phenomena. But not just any quartz veins; it's got to be on fault line. So,
well, now we're starting to get to what we're putting it together, because California is filled with fault lines, and it's filled with quartz, and it's also filled with gold. So it all makes perfect sense when you start to think about it. There's more going on here, and they're getting that quartz to resonate. And what happens? You get all these different processes going on, and you think
Absolutely.
it's the richest state, but it's really going to end up being the poorest. We're going to have a whole piece of it slide off into the ocean one day, because we're just going to hit the wrong resonance frequency one day, and there it goes.
Yeah, Tool wrote a song about that. Learned to swim. See y'all in Arizona Bay.
Yeah, we'll have some ocean front property in Arizona, huh?
That's
it.
Funny. I'll tell you, Arizona, as far as like this sort of stuff is concerned too, is just a super interesting state. Its mineralization is unlike almost anywhere else in the entire country. And then you have the Grand Canyon way up north. And I've been to Arizona a whole bunch of times, so I've experienced it and stuff. But you look at the Grand Canyon and then you look at the Colorado River, and you're like, okay, well, maybe the Colorado River had a different route at one time. Well, maybe the Colorado River was wider and had more flow at one time. Okay, well, at the end of the Younger Dryas, all the water that was held up north of there came through that. But where's the evidence of that? Because there's none north of, upstream of the Grand Canyon. Then you have the Grand Canyon, and it literally looks like it got hit with a plasma ball. It literally looks like a plasma bolt on the surface of the earth. I've heard that before, and it's like, once you see it, you can't unsee it. And once your logic follows that train of thought, it's like you really can't, and then put your tinfoil hat on, but then they don't let you go inside the damn thing. You're allowed to look at it just from far away. Don't want you picking up on it, That's it.
Hey, Joe, Victor says he has let's see, I have a small update on your crazy rock.
Oh, please, Victor, update. Hi, by the way. I saw you in there. We got a little crazy. Yeah, tell me what you found.
Yeah, hold on one second. You know what? Let me just
I'll tell you what, while he's typing that out, or if you want to send him a link to have him on, bring him on.
Yeah.
But I have a piece of chrysoprase that I'll show you. Daniel was talking about it before. It's really beautiful, and I have it right over here.
Give me 1 second. Okay. There you go, Victor. I sent it. It should be in your email right now. So, hey guys, real quick before we get to the rock, I wanted to show you this because Joe wrote a song, and it's for the show here, and I wanted to play that real quick before we got to the rock, Joe.
Yeah,
I just
sure.
want to go ahead and play this. So
Yeah, play the song for the show.
it was really cool. So hello everyone and welcome to Saturday. Oh no, that one wasn't it. We want that one right there. Sorry. Take that one down. Sorry. There we go. Right there. That's what we want. Turn that volume on.
In a world that walks the line, there's a rare few who think outside the box together form a crew to break the equations, not bound to any rule. Exposing to the world the universe's all view. It takes the talent of the craftsman, it takes the mind of the fool to make the vision realize energy and matter in a duel. To a great, to a fool. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie making power. Listen to a word that the straight no says. Mike building batteries that power a ship. Victor comes and talking math, that's the wide spiral dip. Sean chucking plasma volts a mile long. Sheila on the video making tones jump the prom. Burning breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bills.
That's so cool.
Thanks, man. Yeah.
Oh,
Yeah.
man.
Yeah,
That's on
Fish,
Joe's show.
I hope you like Suno. You know what? I play with that all the time. I just find it so much fun. So,
What's going on, Victor?
hey, Victor.
Hey, I got some background noise going on. I got to shut down, I guess. Okay. Can you hear me?
Yes,
Yeah,
sir.
we can hear you.
Yeah, man, stuff has been gelling. I got to hook up with Bernie one day on the something he showed, a guy that mixing triangle, square, and circle. We got to hook up on that one day. But anyway, I've been reading. You guys are familiar with Fractal Woman, and she did the interview with John Mackin, and he wrote a paper on the ether being fluidic as the medium of all, right? Well, I've been reading the paper. I'm a little proud of this. I shared with Fractal Woman an error, and she says, you're correct. It should be 1.043 times 10 to the power of 27. Good catch. I will let him know. So I found something that helped the paper get better. But in reading the paper, I guess I should probably share.
Please.
A window, I guess. Yeah. So I don't know. Okay, there we go. In his paper, can you see it?
Yeah.
I can, yeah.
Okay. Right up here it says, oscillating space-time has a unit of energy density when mathematically analyzed, but it lacks the excitations required to convert a field into observable fermions or bosons. The missing excitations are quantized units of angular momentum, h bar or h bar over 2. Okay? He calls them quantum vortex solitons. They have wave particle duality properties. As this is where I have to give Gerald kudos. His 2-laser idea and the mixing that I kind of said I didn't think would work because they weren't the right colors and amplitudes.
Mm-hmm.
Well, on the other side here, it says, to notice the geometric pattern the rotating vortices make immediately after stirring with 2 rotating laser beams for about 1/10 of a second. These vortices have a random distribution. However, over the next second, these vortices assemble themselves into geometric patterns shown in figure 1. This pattern is known as a triangular lattice or hexagonal lattice. There must be a repulsive force between each vortex, just like atomic orbitals. If you see in picture C here, it goes back to the man, oh God, I don't know if it was Plato or well, anyway, the dot 1, then 2 dots, 3 dots, 4 dots, they add up the tetractys that add up to 10, the source of everything. And then
I could see it in the last one.
Yeah.
There's what do they call it? Kagome. There's a Kagome pattern right in it.
That is where your Kagome lattice comes in, with triangular orbits of the electrons. Okay.
Mm-hmm.
And then apparently your rock, when it's impacting, might be setting up magnetic fields that causes it to disperse a little vortex. And so the coils are the angular momentum necessary to create fermions and bosons in the alchemy. We are getting there, people.
Oh, wow.
The Sierpinski's gasket and all is triangular. So the quantities that he talks, Benoit Mandelbrot on nature, the beauty of iterated systems. This one, where I want to use it as a quantum of capacitance.
Yeah.
They're showing the attractor for it. And this portion of the attractor, right over anywhere anyway, you can see how it bends out like a dipole, and the dipole is folded in upon itself.
Yeah,
anyway,
I see
that structure is all over in certain temples and places where they use columns to show something. They're across the tops of the columns where you would expect to see Doric or floral leaves. They've got those folded dipoles on the tops of their columns.
You know what's a little funny, Victor? That looks exactly like a pattern from like a quilting sampler.
Right.
You know, the way that was. You know that I was gonna say something profound, but I forgot. It's okay.
Anyway, your crystal lattice, and apparently the article says there's all kinds of them with people's names on them. So there's apparently a lot of people trying to make a perfected form of this structure, I believe.
Yes. Yeah, MIT made some after Browns did a big research study on the natural material. But I'll tell you what, they won't tell you what it does. Or they'll say that it has unusual reactions and anomalies. Okay, during moments of excitement. That's their description, okay? Now, MIT was like, we want moments of excitement, right? So they went and they tried to lab grow it. They were successful, except I don't think that they got the secret sauce perfect. And I think that the reason for that is secondary mineralization in natural formation. You see,
forms a quasi crystal.
Yeah, so they were naturally in contact with and inadvertently doped with other materials. And in my case, with my sample, I think it was magnesium that was also present, which would make a lot of sense as to some of the things I particularly saw. But none of these laboratory samples had it. Now, the what I found about it, and the best I could scientifically describe it, was I understood it to be a multiferroic spin liquid. Okay. And they defined it as a frustrated magnet.
Right.
Or having experienced moments of frustrated magnetism. So it doesn't, it could have interacting poles facing opposite directions directly next to each other. Basically, the thing wants to tear itself apart is what it wants to do. But it can't.
To open. Fractal Woman shows something about 2 electrons being paired up, and somehow in the spins they show the twist of the fabric. And there's actually software out that I just downloaded her and someone I think named Chandra or something. They're working together on it. But anyway, the software shows 2 electrons opening up a little nanotube.
Oh, cool.
It's wild. It's stuff she's going to reveal soon. So,
Oh, I can't wait for that.
yeah, me too.
We'll have to do a group watch on that, maybe.
It. Or I don't know. Anyway, go ahead.
You know, with the what I'm saying about the frustrated magnetism and how it creates internal torsion stress in the material makes sense, because sometimes when I was dropping one piece on top of the other, okay, it would lock. Other times it would slide. But anytime it was having any sort of effect, one or the other, okay, it would go from sounding like 2 rocks clicking together to like a piece of metal on glass. It was a very hot, very sharp and high, tink, 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 like, you know, like you would expect from a hardened piece of like steel, so to speak. You know, or, you know, pinging glass, not like 2 rocks just banging together, and not the same sound that when it's not experiencing that frustration. So if you have a pulse swap and things go in all different directions, and, you know, it's unpredictable and goes under that torsion, it makes sense that the actual internal structure itself, potentially even its density, could change. I don't know. Like, maybe I'm just saying that, but
no, there's something in John's work about contraction geometries or something where it contracts as the pressures increase. So I don't know. I'm not done with the paper. I only just started the other day. There was a death in the family, so things kind of slowed down here. And then, yeah, so
I'm sorry.
Things clicked this morning as I started reading and going to all over Medium, reading papers, John's paper, the paper I got on the Kogami lattices from the person that posted it. Thanks again. Yeah, I just seems shit's coming together.
Yeah, that's why I said that rock was super fascinating, because if there was just simply a way to actually make that, and I'm gonna just tell you from my own experience, if you were to make it, it's not like a grown crystal necessarily. It could be partially grown crystal, but as like a compound, it's almost more of like a dull ceramic than anything. You know, I think that's I think that if you had that, I don't know what else you need, really. I don't think you need anything.
I don't know. I have work on the property to do and mowing and stuff, so I can't stay long. But that was just a short update. That was like, yeah, you guys we're all on the right track with different pieces, and as you say, the puzzle, we're getting filled in.
I think, honestly, out of all of us, Gerald's got this thing locked in. He's got some, you call it sixth sense, he calls it from the man upstairs. So however you want to say it, he's got it. And it's coming through, right through in all of his work. I just find it the most fascinating thing in the world.
Right. Well, that article that of John Mackens, if anybody really wants to get into the thing where it's like everything, he's broke it down to Planck length, Planck energy, Planck time, the whole. Yeah, there was
if you could post it in the chat or something, you know, that way I could check that out. I'd love to read it. And thank you so much for dropping in and sharing that. You know, I appreciate it, man.
Let's see. This is called.
Let's see what's doing in the chat. I've learned my lesson. I pulled up a chat box this time on my computer as opposed to my phone.
Yeah, it won't let me paste it.
Oh yeah, so while we're on the rock subject, that was something interesting that someone said yesterday was about bioapatite. Okay, bioapatite is a fancy mineral way of saying bone. You know, bone is an apatite mineral that's crystal structure too. but apatite is not generally piezoelectric. But they were telling me yesterday, oh, well, no, bioapatite is. I'm like, oh, I did not know this. Okay, well, let me look. So I did a little bit, not much research. I still need to read into it more, but I just found this fascinating that bioapatite, okay, is somewhat piezoelectric, okay? And it's more piezoelectric during its initial growth state. So in someone who's young and still growing. All right. And under certain pressures and stress, it holds a charge. This is where it gets fascinating. It holds a charge in the like little crevices and pockets that are on the surface. Okay. And those are the spots where the fascia knows to attach that holds everything all together. So it actually has collagen attachment points. The collagen knows to attach to it because there's an electrical charge held by the bone in these little tiny, pockets, so to speak. Found that super interesting because, like, I did not know that was a thing at all.
I hear you.
Real quick, Victor, if you can drop that in the private chat, I'll make sure it gets out.
Okay. Well, it's on Fractal Woman's website. I guess I could have went there to try. Let's see if this will paste here.
Or just link to the specific video that it is and tell me which one it is, because I don't know.
Okay, I'll try that one. Let's see. She's on.
What's up, Ben? I included you and Victor in my song.
So cool.
I don't know. I feel like I still have to tweak that song a little bit. We'll revisit that.
So I had a question here while you guys are looking that up. ZVS does a duty cycle on the Gravity Flyer. I'll be very honest with you, with that ZVS, you need to control the amount of energy going into it. And that's how you're going to control what's going on the plates. All you're looking for is a field that's just close to static, but not static. And that goes in there. You want to build energy in there so you can saturate the center plate is what you're looking to do. You want to basically make between the bottom and top plate a dielectric. And in that dielectric field, you want to saturate the center plate. Once it's saturated, it's going to grow to a field that goes around the top, bottom, and center plate. That's what you're looking for. And then as you be able to turn on your Tesla coil, it'll move that saturation of that plate. And it'll pull it off of it and create a beautiful feel around this thing. That's what you're looking to do in that. That's pretty much the process going on there, in case you wanted to know. As much as the frequency of the ZVS, just let it run and do its normal operation. If you wanted to change it, you'd have to add a trigger circuit, and you'd also had to add a duty cycle with frequency to that trigger circuit on one side of it. And then that in itself would allow you to change the frequency and allow you to change the actual energy going in. It'd be so much simpler than just looking for the right flyback. And that's an easy thing. It's like, I want to say $15 of the parts on Amazon. You just look up trigger circuit and say trigger circuit from Amazon in your Google search. It'll pull something up. You want the one that goes to 48 volts, not the smaller one. And then you just want something with duty cycle and frequency on it. And they have this little cheap little thing. And it's got a little plate on it, tells you what the duty cycle is, and it'll also tell you what the frequency is. Easiest way to do it is to connect those things to it. You're able to change it easily. Your energy will change because as you change the duty cycle in itself, it changes the temperature in it. And then if you change the frequency, it'll change from volts and amps. And it's so much easier to control that field with that. I generally, that's all I use. And then I can get the correct amount that I want in there. I want to get to that saturation point Once I have the saturation point, you can tell it'll pick up in energy. So one way to show that is when you take your top plate and you take a dryer sheet to the center plate and top plate together, you'll pick up a ton of energy between the two, and it'll start setting things off in your garage, turn off your computer. It'll do all kinds of stuff. So you know that you're getting close to saturation. When you start feeling the thickness in the air and you can feel it in your lungs, you're at saturation. You can time it on your watch and just be able to set it. It is a 10-minute process to reach normal saturation. If you know how to bypass it and accumulate saturation with that dryer sheet, more power to you. Just go ahead and do that. Reach saturation in the center plate. Then you're getting ready to the point where you want to be able to turn the fields. Now, based on distances, when you take that quartz piezo and you pulse it, you're going to be pulsing the bubble. So you have to hit it lightly. Again, we're not looking to hit hard. It's like a diaphragm. You just want to lightly touch it. And then you got the pump. You got something that's going to pull the ether in. That's what you're looking to do. So that's just a kind of an understanding of how that electricity works right there. There's a lot more to the process, but that in general, that's what you want to look for right there. Sorry, guys, go ahead. Did you find Fractal Woman?
What I could, and I put I put John Mackin's link in the private, and I put what I could, but it didn't post to some other people. So,
okay, hang on.
But yeah, it's in there.
There you go. I moved it from the private to the regular chat. There you go.
Remember, one of the very last Planck value that he lived is an error. It needs repaired. The power of 10 is missing. It just shows the times a power, and there's no 10 there. There was a typo that made the stuff.
Okay.
But yeah,
that's why we have you fill in the blanks, Victor, over there.
Yeah, that's right.
Well, I was tripping because that's like I'm looking at the crystal, going, "What could I do with that? I mean, how would that work?" Because it's showing entanglement in the crystal, and then he's showing. He doesn't say entanglement. He says spooky action at a distance, or action at a distance, but that's entanglement. And so, if all of this is taking place at that border in the center of the coils, or in the compression point in the center plate of the Graviflyer, or anywhere that we're doing these pressure gradients, right? And voltage and current. I don't know. It's got me thinking.
Well, I want to show you guys something. So go ahead and talk for a minute. I'm going to bring it up when I find it.
Here, I have a couple of rocks I'll show you real quick. I think they're interesting. There's this one is it's a piece of plume agate that I found. It's always very hard to see because I suck. But it's you can see how this spot right here, see how that's all cratered out? That's generally not supposed to be like that. So I don't know how that formation happened. Usually these should be pretty solid, and if they're not, then it should have a geode or something in the center. But it's all yellow, red, and then this one black spot, which I assume was probably like the top or where the water flow came through. It all has all these craters up in it. This is just a piece of quartz. It's a probably got like hematite and citrine, you know, which is all just quartz. But here's that piece of chrysoprase I was telling you about. It's really nice. See how green that puppy is. You know, it's not even super easy to come across like a good sample like this. You know, it's a little hard to find. I don't usually buy rocks, but I saw this one and I kind of had to have it because I look at that thing. Yeah, that was the Atlantis rock I was saying before, Daniel.
Yeah, I wonder what that would look like cut and polished to as a stone.
Oh yeah.
Yeah, it's really, really beautiful stuff. You know, I do a little cutting. I haven't went in a while because don't have the machinery anymore, so I joined a mineral club. And the mineral club lets you use all their lapidary equipment, but they're only really open on Saturdays once a week, and it's like an hour and a half away from where I live now. So I just haven't been in a while. But I would have loved to have cut a piece of that because it really is stunning. It's like candy apple, or like, yeah, not candy apple. Like it's like Granny Smith apple green in real life, and it's super clear. So probably would have made something nice.
There's a stonecutter and lapidary guy that got me into the pyramids, and I don't know. As a kid, he lived next door to my mother. Had the rock saws in his garage and everything. One day he just called up, and my grandmother called me up and said, "Yeah, my neighbor wants to talk to you." And I walked in. He handed me this book called Earth Energy: The Entrancing Force of 1,000 Names. Had all these inventions and ideas that people had. And another book on activated water. It was a little pamphlet from the 30s or 40s or something. And a garnet, that big, huge, polished, perfect garnet.
That big, huh?
And, oh, man. As I was leaving, I handed it back because I was like, "Oh my God, I would be irresponsible. I'd break it, I'd lose it. You know, I thought it was worth a fortune." And he was just letting me look at this stuff. And he goes, "Oh, not what you were looking for, huh?" He took it back and he goes, "Well, you keep that book. I need the activated water book back." And ever since then, I was like, man, I need to study that. What's special about garnets or pyropes and you know?
Yeah,
kind of
you know, when they were digging out the New York City subways, they found a garnet, like the biggest garnet in the world. It's like this big.
Wow.
Yeah. Like
Nice.
things. I think it was like 11 inches across or something crazy like that. And it was perfect. And it was perfectly formed. It was a perfectly formed crystal, loose. Mind blowing. New York City subway, but. Yeah, garnet's an interesting stone because it's pretty.
Fungus doing lensing. Of course, they're teaching all kinds of things to work for them. Wow, I'm sorry. Anyway, yeah, I've been thinking about your crystal and that lattice and different types of the cupric oxides. Then, while as I read John's paper and contemplate the energy and properties so that the Graviflyer will fly, because she has an actual video where she's talking about quantum states, but yet if you look at it, she rotates it and there's a bubble within a bubble on the top half and a bubble within a bubble on the bottom half. So the electron model is kind of like what the Graviflyer should be able to imitate if we're following Victor Schauberger and imitating nature.
Well, let me show you this, because it's one of the pieces of the puzzle that I haven't really presented to everybody on the team yet, because I'm trying to wait till he comes on. Okay. And it's Brandon's work. And I just want to show it now. So you see this thing right here, right? And you got a lifter. Now, traditional lifters don't carry weight. That's kind of one of the things. Is it ion wind? Well, the answer is absolutely no. It's not. And this is exactly what you're going to get with that piezo buzzer. Something big and something small. You got small wire on the top, big frame on the bottom, right? Your Graviflyer, once it's saturated, you're going to get the same effect that this guy's going to get right here. So let me show it to you. So we'll bring it close to the point.
So he went with a rectangle instead of a triangle. Interesting.
So if you look at it, you can see that thing sitting by itself. How much force do you think he has in that thing? There's no ion wind that can lift that, by the way. Not a chance in this world you're going to get ion wind to lift that weight.
I don't know, just the way that the thing's moving around and also staying within the parameter of where it's like locked into is pretty interesting in itself.
Well, he's got strings on the bottom holding it.
Oh, it's the strings that's holding it? Okay.
Yeah.
So he doesn't want full lift off on it.
Yeah, so it'll go higher. It'll keep going.
I think what you've done there is just show proof then of the stories where supposedly either the lid or the entire Ark of the Covenant could fly around or could sometimes move on its own, and the tribe would just follow the Ark.
Yeah. So what we're getting at, just so you guys know, and I'll remove this real quick so we can talk, is the actual structure of the weight won't matter now. Just understand this. We're looking at the piezo disc. What we're not realizing is it's electrically active on the plate of that piezo disc.
Mm-hmm.
It is now the small object with the large object. So when we look at two power lines, you have the, they call it sometimes ether in the center, but it's really the dielectric that we're looking at. So when you have equal dielectrics, the center gets saturated. When you now create an imbalance, I'm now creating a very small thing in my piezoelectric disc to my very big center plate. I now have that ion lifter. I now have exactly what I'm looking for, right? I can now, when I get to that special state, and Mike didn't understand this yesterday, when you have that thing saturated properly, it is easy as creating those two power lines. That's all I have to do. I just simply invert the field on the center plate. That's the anomaly that comes up in every single one of these experiments that is very hard to reproduce. I can reproduce that effect, that simple effect. I built his lifters. I have his power source, okay? He's shown me the whole thing, but I want him to be able to present it so that everybody can see what he's doing, because it's really special in how this works. You see, the saturation in the dielectric removes the weight. That's the bubble. That's what I keep telling everybody. It will not allow it to stay on there. It's like snow. We simply shook the snow off. We have a vibrating object that won't allow snow to apply itself to it, just like we won't allow gravity to apply to the gravity flyer once that thing is saturated. That's what the red light test showed, that there's a massive saturation around the whole thing. Guys, that's the whole answer. That's this gravity flyer.
Is that aluminum acting as a dielectric? It's redirecting the flow of the magnetic propagation at that point.
It's like that bubble that we saw, John Macken's bubble. He's taken the vortices in the aluminum, depending on the rotational speed, and distributing those vortices out to the further edge so they can be assembled around the craft, perhaps.
There you go.
And the ultrasound, if the ultrasound comes off the metal right, it can Doppler shift into RF frequencies, thereby inflating the bubble. But then you want it to oscillate and maintain without losing electrons. And on physicsweb.org, they just did some research. They launched a couple rockets up in, I think it was Norway or Norwegian area. Anyway, they launched rockets up and found the electrostatic potential of the ionosphere and found the difference to be 0.55, give or take 0.09 volts. It's 0.55 volt difference potential drop. And so it's given them the electrostatic, and they're saying that that bubble of the ionosphere is made up mostly of cold hydrogen ions. So we are surrounded by a very cold plasma, which has the essence of well-being, because cold plasmas.
You just killed me.
You do realize that Tesla coil puts cold energy directly to the center plate of that gravity flyer. You know that's what we're pinging the earth or ether with.
So say it's coming together. It's gelling.
Yeah, it's there. Yeah. It's funny how all these tests come together and everybody working on their different devices gives you a different answer that you needed, that you couldn't come up with on your own device to see it that way. And Yeah. I think, to be honest with you, man, this thing, we're going to be there here in a few months, and that's it. That's what it's going to be. It's that last piece of the puzzle. It's what Gerald's waiting for to get his his thing off the ground. That's it, because he already has the ether built. He just needs to be able to push that diaphragm. That's it. But you also have to understand how that whole lifter thing works, because it's in reverse of natural order. That's the whole thing. And it only has to do with the saturation. It's only when you get saturation do you get that reverse order. That's why it's an anomaly that shows up in experiments. Like 99% of the time, it goes from big to small, and that's the direction. In that 1% is when it reverses. And in that 1%, you have saturation. That's the difference. That's what people don't understand. You're saturating with ether. That's it.
That's what John has quantified. He showed that ether energy densities and the spectral frequencies as they come together in energy densities, which I guess we could look at as atomic orbitals. I'm not sure. I haven't got that far. But anyway, he says that energy density has a unit. And so he quantifies it. And so we can take that unit then, which at Planck length scales, and build upon it. Fermions and bosons. So yeah, you're either if you create a fermion, fermions are limited to the speed of light apparently in the vacuum, but they glide right through it, he says in the paper. So we want to imitate a particle with the ship.
Hey guys, Gerald's in the chat. Just want to say a big shout out to Gerald out there. What's going on, Gerald?
Yes, sir. You made it into my song too.
I'm gonna play this one more time because I need Gerald to see it. So,
Ben, I know that your Game Boy Color was green.
huh,
My brother had one. I was too old.
this is that final piece right there.
Yeah, it's interesting that he used a rectangle, because I've got a book on physics that shows like all these high school answers to these tests, and they show you the experiments to perform. And one of them, I think, was getting a drop of oil to go through a magnetic field and then just levitate. But anyway, I remember reading in there that they said rectangular coils will overcome the force of gravity.
Well, the funny thing is he can make this thing flat. He doesn't have to have the sides like this.
Right, but the shape, it matches.
He can make them circular. He can make them triangular. He can make them any shape that he wants.
Mm-hmm. But even the temple was a hallway. That's like a hallway.
Yeah.
So there needs to be a portion, 1/3, like the back temple where the ark would sit. Anyway, maybe that's the way to construct the craft or something.
Well, the outside is a whole different construction to that, but let me just show you. Hold on.
Well, I mean, technically, you could make that rectangle, as like a Fibonacci, following phi. You just have one big square and two, half-size little squares.
Geometries anyway. Yeah, there's definitely geometry to it all.
Then you pin your center, and in your center is going to be, it's a good place to be.
Yeah, hold on one second. I'm going to show you another one, just to show you that some of the things you think matter in this don't really matter at all. So here's this one that's round and it's flat on the top now, right? That's still not a problem.
So the point then is a large and a small, just like when you're drawing a golden ratio spiral, there'll be a short side and a long side in your squares, and then the spiral keeps going, and it keeps, goes by a short to a long to a short to a long,
so
keeping its ratio.
It's the imbalance in the dielectric. That's it. He's created an imbalance in the dielectric. And because he did, it now has direction.
The induced angular momentum that's in John's paper, which the coil imparts to the vacuum.
There you go.
Okay, yeah. I need to build mine. How much do you need to start my coil?
Yeah, no, I'll get your stuff off the printer soon, man. But the winding and stuff, you're going to have to do that because the weight, I have no idea how to ship this stuff. Let's just be honest. Or else I would have shipped people 3D printers and I wouldn't care. But I just have no idea how to do it. I'll have to ask the wife. Because I know they send me the wire and it's free shipping. So I never looked at the weight. You know what I mean? And these coils weigh a ton.
Yeah.
If you're recommending stuff to people, like, you should set up an affiliate thing with someone, you know? That way, when people are kidding up and stuff like that, then, you know, you can get a little piece of it and fund some of your projects and everyone wins, because it's not like you're taking money from them. You know, they're getting what they need, and you're getting a little slice of it for recommending it. You know, might be worth thinking about.
How to do that. Because, yeah, there are certain people I'm recommending, because as I'm learning, like that one fractal, I don't know if you saw it, it was folding and unfolding. It's called a dragon fractal or a highway dragon. Dr. Adrian Marsh, besides doing golden ratio discharges with his high pressure Tesla coil, he's got it up now. I guess I have to go watch it. He's got the dragon fractal coming off the tips. And I see a way that the dragon fractal, in the transforms where they rotate it, it starts out as a plane, goes through some fractal transformations, and then comes back into another plane. I think that's the system we can use to translate the energy from point A to point B in the Alexanderson antenna. And Dr. Adrian Marsh just happens to be working with EPD Laboratories and Eric Dollard. So I see pieces in my neighborhood and California and Nevada all coming together. And yeah, hope.
Hold on. I got something. Let me see if I can't. I'll take a picture of it real quick and I'll show it to you guys. Go ahead and talk on. Get this figured out.
So I have a little bit of absolutely unverifiable, I don't even know, I believe it, conspiracy that I came up with. There was you know, I told you I live right by Wardenclyffe, which is right by Brookhaven National Labs. So Wardenclyffe was like shut down in like 1917. Tesla was out of there. They basically boomed his tower, realized that the stuff isn't worth anything and scrap it. It's not worth breaking down. And they wouldn't let him have his generator. They locked the place up and it sat there. You know, World War I, World War II. Just after World War II, you know, they started planning the development of Brookhaven National Lab, which started in 45 and ended in 47 and opened up. They moved them in a lot of the residuals from the Manhattan Project to Brookhaven. Okay, and they built Brookhaven National Lab exactly 5 miles on the dot from Wardenclyffe down the only road that exists. It's one road straight from Wardenclyffe to Brookhaven, 5 miles. Wardenclyffe was bought out and basically gutted before it was repurposed. And that was right at the end of the war that they did it. And I'm sitting there saying to myself, well, then Tesla died in, I think, like 42 or something like that. It was somewhere in there. I could look it up. But nonetheless, so I'm sitting there saying to myself, they didn't think anything of Wardenclyffe. Then he died. They grabbed his trunks of files, went through it, realized Wardenclyffe is probably just riddled with all of his useful stuff that they threw him out of, sent in a crony to go and buy it out, and then bring all the stuff to Brookhaven National Lab, which then Brookhaven National Lab is where supposedly Philadelphia experiment, you know, if you want to believe that, you know, whatever. That's where that took place, and that was also the start of the Montauk project before it moved out to Montauk when it was under Project Phoenix. Okay, so Project Phoenix was a regular budgeted operation through Brookhaven National Laboratory. Then when they figured something out, they decided that they couldn't, disclose what they were doing, so they moved it out to Montauk. And according to the government, Montauk never did anything after it shut down as Air Force Base with the radar tower. So, again, little conspiratorial, I suppose, but the timeline looks good. The distances look right. When all the projects fell into place and where it moved to all seems to add up. And the stuff that they claim from the Montauk project, that's directly in line with the sort of technology that Tesla was also ultimately messing with. So, briefcase, Wardenclyffe, Brookhaven, Montauk. That's how that went, in my opinion.
Tesla was creating cold energy at Wardenclyffe. He put it right in the ground. He never intended it for it to go in the sky to light things up. That wasn't his goal. He was going to do it through the dielectric in the ground. He's putting light bulbs in the ground. He wasn't putting them in the sky.
Add pressure, everyone could tap. They could tune in.
That's right.
Have you ever seen those videos where a man, I think it's from the 50s or 60s, a man is showing like a transmitter, and he tuned a frequency, and he goes over to his electrodes, and he plugs in an induction heater and puts a fry pan on and fries an egg, and sits on it, and it's on his lap on the newspaper, and he's frying the egg. Then he pulls the coil out and changes the frequency, and puts another device in and melts metal, and all of this is being done with his transmitter.
Yeah. So I want to go one step crazier. Something I just thought. Sorry, I didn't mean to cut you off, Victor.
I'm just wondering why our kitchens don't have that. We have to buy a separate microwave, a separate stove, a separate refrigerator.
So with Montauk, and I just kind of put this together as I was thinking about it. What they supposedly did in Montauk was they opened up a portal, okay, and they were doing all sorts of mind control experiments and interdimensional type experiments down there. But again, Tesla tech, and supposedly whatever happened that shut down the project, they needed to cut the power to, or so they say. But what I realized is they never said try to cut the power. They said that they cut the power line, and that the power line was something like, it was astronaut. It was this massive cable. And what I'm thinking to myself is, I never considered whether that's electricity going in or out. Because if you have a portal that got out of control, and to the point where you filled it with concrete, the whole entire underground structure, which we had talked about previously, I was like, there's eyewitnesses that say trucks came for months until literally every single tunnel was, spewing concrete out the tops of the manholes from the vents everywhere. And I've seen it with my own two eyes. So, I don't think that they try to cut the power to it. I think they try to cut the power away from it, hoping that it would collapse.
That'd be interesting.
I thought that happened at a rather distinct height in the sky in a certain city once.
What, over Russia?
No. Something about possible portal connections and not being able to break it, so happened to destroy the buildings and then happened to destroy the building that had the computers with the data, and then of course happened to destroy the people that were watching it.
I didn't know that was a theory.
That's my theory. I think the Pentagon and the building next door had the computers. The Pentagon was monitoring it. The Gates ran away. They had to dissolve the whole project. I mean, literally dissolve.
Interesting.
It fits to a Marvel Comics thing, top of a building with an enemy coming through a wormhole, and okay, whatever.
Yeah, it sounds out of a Pulp Fiction magazine.
Hey, what better cover up than to make a comic book in case anybody figures it out? Oh, who knows?
And they say the best place to hide something is in plain sight, you know?
Yeah.
I got something to share with you guys. To show up, yeah. So just so you know, this is the field on the Gravity Flyer. We're talking about saturation. You can see where I drew it, and you can see on the right-hand side where the plates are and where it is. But when you look on the left-hand side, notice that field around the entire center.
Mm-hmm.
It's right there. It's saturation. That's what it's going to look like when you do your power lines. And if you can ever get it dark enough and see the lights, that's what you're going to see. That's same saturation. Now, I'll show you the other one. This right here, let's see. That's the lift that you need to achieve. There's the small piezo disc. The disc itself, not the actual piezo part. Disc itself is going to become electrically charged. When you push that against the other one, it's the top disc and the center disc. That's the lift that you're going to get right there. That's basically the answer to this thing. So I just wanted to show you guys that. It was pretty interesting, just so I could finish that. We can go on and talk about the other project and mind control if you'd like, but it's the answer.
What you showed just reminds me of where Eric Dollard says that when you have two plates and they're charging, they're under stress this way, but the energy's coming from the ether sideways. So it has to build up, and we have to twist it into the model we want.
That's right.
And so that self-similar curvature is our dragon fractal going off in two directions to wrap around to build the bubble. And I've got a thing off. I'm following some people on Medium in Cantor's Paradise. I'm reading the articles there. And Adrian Marsh's, I haven't seen it yet, but I know he's got the fractal discharge. And I think the key that he's doing is in his design, it's a certain pressure that he is controlling, almost as though your cone with the tip. He's got his frosting coming out just right.
Oh, hold on. It's better that cone one you showed with the circle around it, how you tap the plate and it starts to turn. Okay? That's really what you're doing. You just said it. You just have to change the energy. You said it was going like this, right?
But it's in a field.
So tap, 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 tap. You're in the right field. Boom. Now that's
right. You need that density in your capacitance to be charged along the outer rim, going from your two rotating plates out like a cone to the edge. And once it bursts off the edge, you don't want your energy thrown away. You want it wrapped around you.
That's right. That's why there's
so interesting thing about the wrapped around you part. And, you know, maybe the energy just inherently would flow that way. But I discovered this, and this is one of the things that actually brought me down all of these rabbit holes to end up talking about this today, was when my daughter was born. All right. She had Dr. Brown's bottles. Dr. Brown's bottles had venting systems. Venting system is a cap, okay, that has two vents out the side of the round part, a depression in the middle, basically like a little tit that sticks up out of it, like a little tube that feeds out those side vents. So when I was washing it one day, I realized something. If you flow water into it where it's going to hit the one side of the internal vent part, and then the external piece of where it wraps around to go into a tube, a separate piece, you'll actually have the water hit it at such an angle that it vortexes one way, and then hit the other side at such an angle that it's vortexing counter-rotationally through this venting system by just having basically a hole within a hole and having it, proportionally correct where the water hits it at the right angle for it to do this. Okay. And I was able to replicate it over and over, and every single time if I had one on me right now, I could do it and it would happen. what was even more interesting, or just as interesting, I should say, is the tube that it attached to, okay, was wide where it connected to this little saucer piece I'm telling you about. Okay, it maintained that width and then tapers down to a narrower tube. Okay, and that's just an interesting effect too when you're thinking about water flow and that and rinsing it out. When you rinse it at an angle, it creates an extreme vortex, much more powerful than the water coming out of the faucet would suggest it would make instantly. And it would immediately flow even faster once it reaches that point of compression. The only thing is you get a lot of splash out.
Yeah.
But now here's where it gets crazy. If you were able to do that, but also have it connected to that top piece simultaneously, which I was going to try, but I wasn't about to cut apart the bottles. Okay. You could do this simultaneously. Then you would have one very, very fast rotational force out. And then you would also have two counter rotating forces in the opposite direction from the splash if you could tune the thing right. With the
Isn't that what Ben Malcolm says he's got figured out with the spheres acting as the return?
Yes, but his isn't that complicated, and his is separated. See, his system is balls within balls and tubes within tubes, and it works great. So that's not the point. The point is that what this does is it creates suction one way, and then pressure the other way, counter rotational, all in the same exact vessel.
So you're modeling
creating a vacuum. You would have to create a vacuum.
You're modeling a magnet then fluidly, right?
It's basically a fluid magnet.
One out. Can you make it recycle? Or put a turbine in the center somewhere to get work out of it?
I gotta play with it some more. I gotta see.
If you can,
but
you'd have
it fascinated me so much that I could never wash a bottle without being like vortex, vortex, vortex. You know. But
when I'm washing dishes, I spin the plug and let it. Yeah.
Yeah.
All right, guys, I got something to show you here. Check this out. We're talking about the vortexes over there, and you're getting ether, and this is Gerald's thing. So normally you'd think of it like this, right? You come in the center, you come out, and then come back in to a point, right? You know why that doesn't work? You have an electrical field on the outside, so it cannot come back to the center. So you have your sphere, you have it coming out like this. You naturally would say it would come back in, but if you have an electrical field sitting there, it'll push it back out, so it forces it to stay on the outside. Now, what that does is it makes it combine the top and bottom field. So as it comes around, you normally say here, it doesn't. It comes around, goes all the way full rotational. So as you do that, you get that. Okay? So from that, now all you have to do is draw your dotted lines to understand what you're getting. Now you end up with this. This is the same thing we're getting on the gravity flyer. That's how I know there's a vortex in there. What those are is your electricity lines, not exactly static, okay? But it's pure ether energy that's going on in there, creating that vortex. You have the heat on the outside, and you have the cooling on the inside. That's why my gravity flyer plate drops by 20 degrees in the center. Just the center. The outside stays at room temperature. It's still got heat to it on the outside, but then it's cooling on the inside. So that's why I say you push the diaphragm. Not you push the entire bubble, but you push the diaphragm. It's the same thing going on in Gerald's coil. You have that field. You have to just remember that you created a magnetic field on the outside. So it's now not allowing it to push in. You don't see the earth cut in half. You see it as one whole because it doesn't let it force in. It keeps pushing that energy out and causes rotation. So that's by the way why you're getting your rotation in. That's causing your swirling on the top and the bottom. That's the whole ball of wax right there. That's why you're getting your vortex the way it does.
Can I make a? Do you have that picture of the Egyptian obelisk where the tuning forks were wired up? And you were
I have
showing
it somewhere.
how they-
I do have it somewhere. It'll take a minute to find, though. Go ahead and talk. I'll look.
It seems that contains what you just drew. I
Yeah.
remember seeing it on that obelisk, exactly what you just drew. And it makes me think of a way to interpret the obelisk and what you just said. It's on that obelisk.
Well, Egyptian culture has all the answers to this if you can read it properly.
Yeah, you just gave me a way to look at it by showing to what you just said. I think I can interpret it. Or I can give a.
There's science formulas. There's science formulas. That's all they are.
Isn't the cup? Doesn't the little cup that was underneath the two tuning forks? Isn't that the letter C, which we use for the speed of light?
It might be. Give me. I'm looking for it. I'm trying to hurry right now to find this thing because the answer is definitely right there.
That's an interesting connection.
Oh man, I usually have it somewhere.
Well, when I was talking about those three numbers that are square and tetrahedral, 1, 2, and 140, if you take 140 and square it, you get 19,600. If you consider that a frequency that's almost ultrasonic, but not quite, it's audible enough to hear. And Hathor was supposed to have these rattles that produced ultrasound to create a sense of well-being. 19,600 may be a starting frequency for ultrasonic and crystal researchers. And your coil.
19,600, huh? Write it down.
Okay.
140 squared.
Hold on, I found it. Give me 1 second. I'll bring it right up. And there you go.
Okay, right above the cup. If the tuning forks are vibrating and there's water in the cup and the tuning forks were set on the edge of the cup, it makes the four-leaf clover you just drew in the water of the cup.
Yes.
And there's a
There
cup
you go.
above it with something in a cartouche. That would probably be once the sucker's on, perhaps. Anyway, that was just something that made you, when you drew it, I was like, I've seen that. He has it somewhere.
Absolutely. They gave you all the answers. You just didn't know how to read it yet.
So you have to thank the Egyptians, okay, because they're not the only ones that figured it out. They're the only ones that took the time to put it down in a way that would stand the test of time.
And on
Yeah.
one tuning fork, you have 2. And on the other tuning fork, it's 3. The 3 to 2, 2 to 3 that's been getting mentioned in chat. The 1.5, the perfect fifth.
No, leprechauns travel on elf waves.
Hold on. Look, Leprechaun travel on anti-gravity. That's great. Oh, what's up, Crypto?
Hey, Barney.
I just find it interesting every time I look at Egyptian stuff, or I always want to call it pre-Egyptian, because when you look at certain places, there are actually different writings that are going on, and you can see the difference. So I forget which temple it was. It might have been, I don't know if it was Hathor or what it was. I think so, but the writing in there and the people, the way they depicted the people, were completely different than all of the rest of the newer ones. And they also did things in reverse. I think that they made things pop out of the stone, and now in the newer ones, they made them indent in the stone. So there's a total different way on how they're doing it, but the inside writing is different. And you wouldn't normally pick that up unless you knew that there was something different in the formula that they were presenting. they tried to copy somebody else's culture. They were trying to adapt it to theirs, and they made words out of it to make sense to them, but that's not how the formula went. And you have to go back a little bit to see it.
Well, you also have to remember in Egyptian culture, there was the cubit that was the length of an arm, pretty much, standard for the people. But then there was a much more refined royal cubit for the priests. So the measurements is like Straight Dope said, what, you know, the difference between imperial or Egyptian or whatever, scientific notation. We have different measures. So yeah, they would each express it in whatever their culture was. Yeah, anyway.
Yeah, you know, like my take on that whole imperial metric thing, and even like, and then the even more ancient ways, it has nothing to do so much with like, and I know you've caught on to this, Victor. It's just if anybody else kind of missed it, and not so much to do with the actual measure itself, but rather the relationship between the measure. So you know what, everything in metric is in 10. You know, whereas everything seems jumbled in imperial, but at the same time, you know, when you're talking about an inch, you're really talking about a 1/12 of a foot. So you're talking about a fractional 1/12, so it's a 12th scale vortex as opposed to a standard 10. So when you're talking about then a fraction of an inch, now you're talking about a half of a 12th. You know, so which is a third of a foot, whatever. You know, I'm not doing it right in my head, and I don't have it written down. Stupid.
Thank you.
You know, but now you're talking about 1/12 of a foot is an inch, but now you're talking about a 16th of a 12th is a 16th of an inch is to a foot. It's these fractions that are the relevant, you know, proportions. The proportions. That's what it is.
Fractals are the intermediate.
Fractal proportions, and that's why metric is broken, and you can't do this stuff with metric. That was my takeaway on it. Now, I'm not saying that metric's bad. If you're building something, you build it with metric, it's fine. If you're building a coil and you're trying to have it be in tune with the Earth, my understanding is that the way that the fractions align between a 12th scale on a foot and you know, a quarter, eighth, 16th, 32nd, 64th scale on an inch, okay, are the proper dimensional proportions that you need to have something be in tune, whereas a millimeter doesn't follow that same vortex math path.
I got a question then. How do you think this fits then with the world or the system then?
I don't know. That's why I was asking you.
Well, okay. 12 divided by 10, two different systems, right? That isn't based in the 12 musical. 12 divided by 10 is 6/5, 1.2. The 6 and the 5 is supposed to be a relation, magical or property to the Earth. The 6-pointed star and a 5-pointed, how they mix or something. I can't remember that.
Star, 5-point star, yeah.
6/5, but there's something there then, incorporating both systems. Because the 12 divided by the 10 would be 1.2.
I mean, I found that the 12 was more significant because it's based on threes. You know, thirds, you know, third being a quarter and 6 being a half.
The Bible code.
Yeah, I've been looking at that. 12 and 13.
Because like, okay, so Malcolm Bendel said that the proportions you have to use when making his pipe, okay, was your inner ball of the sphere. Both spheres it has to be in a proportion of 1 inch inner sphere, 2-inch secondary sphere, 4-inch outside sphere. Then the pipe that connects the two spheres has to be either 6 inches because 3 inches is too small, 12 inches or 24 inches. So
that follows the dimensions of the box supposedly that Tesla built and put coils and wires in to power the Pierce Arrow. or to receive it or whatever. Is a 6 by 12 by 24-inch box, a metal box. Is what I read anyway.
So let me ask you the dimensions of some of this stuff. Do you think it has to do with the time? Because say for instance, it takes this amount of time for something to develop, then this amount of time for something else to develop. Do you think there's a correlation that he's doing there that we're not realizing in how he's breaking out the pattern?
Well, it's period doubling, like the Rodin coil, 1 inch, 2 inch, 4 inch. And if you want your cold surrounding the hot, you expect that hot to get mighty hot, you're going to want twice as much cold, right? To balance and keep that thing from exploding when it's put on someone's engine. And he's got it. So
I'm going to run this thing on cold energy. I'm just going to take tap the center of the Tesla coil, put it right into my coil, and find out what happens. Because I want to see if this thing starts to freeze over. Like if it's going to create a vortex in the center, it should get a lot colder. So I want to see if it's actually going to do what it's supposed to do. So
has anyone taken a piezo buzzer and 2 magnets, and don't let them smack, but just carefully put the magnets in pressure on the piezo and see if they get an output?
I have that experiment right here in front of me, somewhere.
You've done it?
Where's my stuff? I got this, which is very hard to hold. So
yeah, don't let them click hard. It might break your piezo crystal and have it. I mean, it'll probably still work, but.
Oh, I got a box of them. That's all right. We'll just keep going.
I have a broken neodymium magnet.
If crystals under pressure release electrons, that thing should do something.
A piece of quartz. So what do we want to do?
Just squeeze the piezo buzzer with 2 magnets. Let the magnets squeeze the piezoelectric buzzer.
Oh, yeah, my magnet's not going to be strong enough to do that.
It doesn't have to be a lot of pressure on quartz, does it?
Well, this is a barbecue igniter, so this thing's going to take a little bit.
Oh, yeah, that's an impact device. Yeah, that's going for the burst. We just want the slow pressure on it's just an idea. Or maybe it would take a stack of piezo buzzers and 2 magnets to squeeze the stack. I don't know. It's an idea that I've been thinking
That is an idea.
Yeah, after watching the guys on reactionless little motors that piezo stacks that can move.
Yeah, once we know we created a vortex in something, it's always good to push that vortex and see what it does.
Oh, yeah.
Like Joe explained it when he was going over his theory that when the vortex is there's no frequency in it when it starts. So we'll find out to tap it and give it the frequency. So we're going to find out what it does. I know that the piezo will amplify everything in there.
Yeah, Gerald, the center of the coil is what gives us the angular momentum to force the charge to do work and take form. We can get the charge, but the coil has to impart the angular momentum. That's what the Oscillating Space-Time paper by John Mackin says, that the quanta of the vacuum has a unit, a quanta, but it lacks the angular momentum to get put into action, which is kind of like people sitting there with good ideas. They just don't have the stimulus to impart the idea. That's where I was.
It's not nice, Victor.
You guys and Old Man Builds and the Gravel Flyer.
Can you guys understand this from John Gray?
10 inches times square root 2 equals 14.1. Half of 10 is 5. 10 and 5 is 15. Okay, 15/16. 14.1, which brings us right back to square root times 10. Okay. Someone understands it. It's a way to calculate 45-degree runs into pipe trades. Huh. So square root 2 is like all over. And 10 again. 16th part is getting mighty. I don't know. Yeah, is that Gerald? WPG Enlightened?
Yeah, that's Gerald.
Okay. I heard it's under your bed. So the song told me.
I'm telling you.
Oh, that's so great. Oh, Gerald.
Right, Anwar. That's like a top stopping, right? It hits the table and wants to spin the opposite way. So we would have to control and flip them. You think the pulse flips the top so it keeps going? Juggling angular momentum from north to south down the center?
Yeah.
Yeah, I got to mow the lawn. I'm just enjoying this too much, but I do got work to do.
Well, the funny thing is I can show you on the oscilloscope, man. As soon as you hit that piezo buzzer, everything amplifies. So if you hit a point where you got a natural amplification on one of these rodent coils where they cross, well, then guess what's going to happen when I hit it with that piezo buzzer? That whole signal is just going to go absolutely nuts. So it's one of the tests I wanted to do. So I wanted to see if there was an ether in it first when I did the cold electricity so I can see, hey, do I have it? Then can I amplify it? So, okay, hold on.
I got you, John Gray. Yeah, we used to use that formula when I was in fabrication. You know, we used to cut and bend pipe and stuff like that. And had it all written down one time. It didn't even ring a bell. But you know, when you bring it up, you know, that's exactly how it's done.
There you go. There's your answer for you, Victor.
I wonder, someone kept saying something about, remember, bismuth was in there, and I kept thinking, yeah, I think the center plate should actually be like some kind of composite, or to like make it carry, I don't know. Anyway.
Well, you know what? Let me say this so everybody understands it, because I've heard a million different things they want to use. Okay, the aluminum keeps the fields off of it. Once you enact your Tesla coil, that field has to be built that way. Okay, you cannot go in there and change the materials. Right. I don't care what you want to put on it. I don't care what magical sauce you want to rub on it. It has to be aluminum, period. It's the reason, because you're trying to overpower something, or you're trying to take an idea from something else and put it on there. There's a reason why you put the aluminum in there. It's the aluminum keeps the fields off of it. That natural eddy current field is exactly what you were looking for. You just can't over amplify anything on this. The second you do, you lose the whole thing. You'll lose all of it.
Nathan, I have a question about that. I have a question about that.
Go ahead.
Can it be something other than aluminum?
Thank you for that. Why don't you just go ahead?
Else had asked,
no. Just go ahead to the punch. Tell me about all the strings and everything else. So when I lift this thing off the ground, I can hear it too. Okay?
Well, if it were something else, then it would have to carry those vortex eddy properties the same way out to the edge, like we discussed earlier then, right? If there was some other material that could translate those eddies the way we want.
No, this is silly. This is a legitimate question. I'm sorry. Before it goes.
But aluminum was what Tesla's... Go.
Oh, here we go, Gerald. Thank you for that, Gerald.
Do you, for real? Do you know, like all aluminum has an oxide layer. Do you think that aluminum oxide layer, if you
could amplify it,
it would cause a different effect?
I think a natural oxide that builds on the aluminum sitting out in the weather may add to the effect.
Add to the effect. That's the question.
Okay. Yeah, because that's what's in your triangular lattice in your rock is copper, oxygen, copper triangles, and it's an oxide. So the aluminum oxide, I didn't think about the oxides. Yeah.
So now I'm going full circle a million times. I've done this before, but it didn't really gain any traction. But now maybe in context of the aluminum oxide, okay, and the fact that it probably amplifies the dielectric effect, all right? Sapphire is 6-pointed crystallized aluminum oxide.
Corundum lasers, yeah.
Corundum, exactly. Okay. So.
Oh, good point. Duh.
So now, you know, like, what with that? Because they make it optically clear in a laboratory where it's absolutely flawless and perfect.
There's an
In fact, if you have an iPhone, your screen's probably made out of sapphire.
Yeah, we need that hydrogen cold plasma like the Earth for the bubble. So the aluminum oxide is giving us an ion that's from the Tesla then that could distribute to make the bubble. You're right. It's got to be aluminum for, yeah. We don't have a material yet not in our.
Yeah, but I mean, so the question about the sapphire though is, does that have, like, what different effect would that have than quartz in the previous discussion that we were having, as far as, like, you know,
the free energy,
since it's made out of aluminum oxide? Do you follow that question, or?
I'm not sure. You got crystals in there with aluminum oxide, and I'm just kind of lost.
Well, the crystal's made out of aluminum oxide. That's the point.
Oh, okay.
Yeah,
And
the crystal is aluminum oxide. Only. That's what it is.
Okay. So,
corundum, yeah.
as far as I know, how do I say this? You have to take basic structures and build with them before you get to a fully comprised structure, because that may nullify the effect. And that's why we just go with the stuff that builds on the plate instead of putting, say, crystalline structure in there. That makes sense? So it has different effects. I always say this. People often try to overpower the system, and in doing so, you're completely ruining the effect, because you're going for one effect. There's 3 more that got to link into it. And by taking that one and amplifying it, you're ruining the other 3. You have now nullified the other 3. So now you do not have something that you need. So the way he balanced it was be able to put in one effect and have it do other things. Okay? That's the whole point here. When you start adding things to it, you add a stiffness layer to it in some way. You start putting things that don't belong in there, like an extra plate. You start doing stuff like that. You're adding a rigid structure to a thing that has to be in vibration. The vibration carries the beat frequency through the craft. Well, yeah, can I put thicker aluminum in there? Sure, I could. Is it going to give me the same thing that I need from the thinner aluminum? Absolutely not.
It would make sense. That diaphragm vibrating is how the bubble then gets the vibration it needs to maintain its diameter without losing electrons.
And you cannot shift. You can't shift the aluminum if it's too hard. Like when I tap that plate, you can't go through those cones like you were saying without that plate being that thin. It won't do it. You can't change the angle.
What's that thin though, Nathan?
The center plate has to be thin aluminum.
No, I understand. I'm saying, like, how thin are we talking?
We're talking less than an 1/8. It's pretty much a 1/16, and then it's, you know what I mean? That's about it. So, yeah, there's a whole series of things that go into it. It's not just one process. Trust me. If we just wanted to amplify something in there, we just put copper in there and amplify the living daylights out of it. It's just not the case. You have to take into consideration the other factors. That's why when I did my videos and my series on it, you'd hear me talk about the harmonics of it. You'd hear me talk about aluminum being the, what was it? Oh, God, the tone of the singer, okay? You're actually just changing what it's supposed to be in the octave of the singer, okay? Every time you went to a different octave in it, it would change it. Victor calls it the way it goes through cones. Okay. It's all the same thing. When you know that you can tap the plate and achieve what you want to, tapping the piezo buzzer is just a different way of doing it. So I've shown in testing, you push the button and you can hear it tap. I know where the frequency is because it falls back inside the ultrasound device itself. So this is all relative to what's going on here, and you only get those effects with the right materials. When the wrong materials are put in there, okay, you get a totally different effect.
There's a distance then from the center plate to the piezo that has to be considered because of the speed of sound to change the vibration in the main carrier. You're using it, that center plate as a carrier wave. And the ultrasound, yeah, you would have to have that distance also figured into your geometry with the square root 2, like he said.
Because, okay, when you go to the gravity experiment, right, with those little styrofoam balls, we know that the wave goes here. We know that the wave has to catch something and bounce something, right? You're bouncing it to catch that upper plate.
Standing wave.
There you go. Now, when you push the diaphragm, what are you doing? You're actually pushing it down, catching it, and pulling it up.
Pulsing the standing wave around. Yeah.
You start to see what I'm getting at. There are so many different things you have to consider in doing this. It's not just, let's just put some bismuth on it and, you know what I mean?
No,
put a little
that makes
elbow
sense.
grease and stick it on.
Mr. L said yesterday in the comments about the sympathetic resonance in a music shop. You go in there, you're testing out a guitar, you hit a string. You know, if you hit it, you actually let it go. You know, you'll have sympathetic resonance of all the other strings that are properly tuned of the instrument surrounding it. But what I've observed is a little different and proves your point exactly. And I mean, something that you ought to know anyway. I used to have two basses. One had metal strings. One had nylon strings that I had on it because the nylon strings were just gnarly and sounded really cool. You know, I could have them both tuned perfectly, where the note should be the note. But if you hit one or the other, they would not sympathetically resonate with each other because they're not the same material. That's the thing. Like, just because they were in tune with each other doesn't mean that they were at the material resonant frequency wasn't the same. So there's an offset. Yeah, that's something I've observed, but I never really thought about it all too much.
That's why you get an offset in your Tesla coil, because you're using very big copper on the outside for the number one coil, and it's a 1/4 inch hollow, right? Well, all the other wire you're using is solid copper. And that means that every time that you resonate, even though you put them at the same exact frequency for both the coils, they're going to resonate at a different frequency once they set. That's why. People don't take that into account because I don't think they know it. That ZVS forces you to break this down. That's what it does. Because it only resonates in a certain frequency, only a certain range. So it cuts down 99% of your options. You get that last 1% that you can work with.
Yeah.
So some of this stuff, by the way, on these coils, if I'm not mistaken, and Gerald will probably tell you this better than anyone, you have to change the capacitance in your coil by the load. That instead of changing your capacitors, you're changing your load to get it. So it's just a different way of seeing it.
No, I just had a thought, and I just don't want to upset you right now by saying anything other than aluminum, so I'm just going to shut up. It's not other than aluminum, but
it's all right. You know what? People will understand soon enough.
I understand the aluminum. I do.
No.
And what's people's problem with aluminum on top of that? It's a readily available, inexpensive, easy enough to work with material. Like, I don't understand what the issue is here. to make things more complicated than they have to be. Like, just I'm not really sure.
Yeah, it's just that you have a bunch of thoughts, and let's put it this way: if I'm reverse engineering your project, I don't change it. I build it your way with your dimensions, with your products. That's it. I don't change it. I don't add what I want to. And Dollard always said this. Okay, he wasn't a genius because he recreated all of Tesla's stuff. It's because he didn't change it. He kept it exactly how it was, exactly how Tesla told you to build it, exactly got the same answer Tesla did. Then he knew what was going on. In reverse engineering, it works exactly the same way. You do not change it. You do not play games with it. You do not add stuff that doesn't belong there, and you'll get the same answer as the inventor. That's how you do it.
I'm on board, man. Nice.
I got a lot to think about. I just wanted to share that one point in the article in your rock, and yeah.
Yeah, no, thank you, Victor, for bringing that up. I mean,
yeah, I appreciate it.
I got work to do though, so
yeah,
I have to cut it short for my share. But I think I got enough to learn from that to think about. Can't wait to see Gerald's reveal, and I want to talk to Bernie and maybe shoot a video talking about a certain concept that he showed on a program dealing with star forts and a pattern of frequency mixes that creates a star fort pattern. So
that'd be cool.
Tripping and finds that little clip. I have some reveal to discuss with him.
You hearing that, crypto? You got to get on it.
So anyway, I'm gonna cut it short then and say thanks, and I'll watch the rest of this later.
Thank you so much for coming on, Victor. I mean, as always, it's it's awesome.
Thanks for sharing. I'll start. Yeah, Gerald, we should, because you had a point, and I degraded that point about the red and blue laser, and I found out in John Mackens that the lasers stir up the quantum because he actually puts 0-point energy and the ether in there, and so you had something, and I just counted it because I didn't quite grasp, but I've been enlightened. So later.
But by the way, you have to know Gerald has it, right? I mean, you guys get that, right?
That's what I'm saying. That's why I had to come in. Straight dope crystal structure with the Kagome lattice, my Sierpinski's gasket, oscillating space time from John Macken with the triangle. It's all there, plain sight again. It's just puzzle pieces have to be brought to the people that can use it. So
that's right.
Yeah, fun time. Thank you.
Always, Victor.
Thank you.
I'll catch you on the next one, man.
Yeah.
Oh, that was cool. I always love it
when he's on, man.
He gets so excited. That's what I love about it, man. Every time he gets excited, I get excited. It's so cool.
Yeah, for real. And when something hits him, it's always such the perfect, genuine reaction. He's like, "Wait a second, it came to me." It's like, "Oh yes, it did." I love it.
That's right.
Amazing.
Absolutely amazing,
man. What a wealth of knowledge. You know, it's awesome. Yeah, what we got going on in the chat here, and catch up with that. Oh, my buddy John. Yeah, that's my friend John from Texas. What's going on, buddy?
Right here?
Yep, John Nat. That's my friend.
Right on.
Yeah, man. Yeah, that Kagami lattice that I was talking about, but then he was talking about in the whole 9 yards.
Yeah,
it's supposedly probably one of the most versatile patterns in the entire universe because it can just repeat and repeat, but it could repeat in more than one way, and it could attach at different points. So it's super versatile and super interesting, and it's only a 2D lattice.
Really?
So it could stack and stack and stack, and it could stack perfectly, stack offset. Very, very crazy stuff with that.
Very cool.
Yeah.
Huh. Oh, yeah. Something in my eye.
Yeah.
All right. Oh, sorry. Let me remove that. Trying to get rid of it. There we go. Sorry. I wanted to show those crystal caves.
Oh, yeah. Show those. Which ones did you have in mind?
Oh, hold on. I don't know where they're from. I just pulled the pictures. So you might be able to tell me. It might be in Mexico.
That's the Mexican one. Yep, that's the one. That's in Mexico.
Okay. Sorry. Let me load up bigger.
I would kill to go there, man.
Oh, yeah.
Like, unbelievable.
That's just amazing. The size of these things.
Yeah, right. That dot in the center, that's a human being.
Yeah. A dot in the center.
So what's crazy about a crystal formation like this, right, is this entire cave at one time was filled with high saturation brine solution. And these just formed within that mass amount of solution to that size, but then it drained out before it solidified. See, what's crazy about this is the only thing that separates this occurrence from like a massive vein is the fact that it didn't take over the whole entire area. But
yeah,
usually when there's that much fluid to cause that to happen, it's not going anywhere, and it's gonna solidify the entire area with the material.
Wow. It makes you wonder what's behind some of the walls. Is it like filled in there? You know what I mean?
Yeah. I could only imagine that if that's going on there, that whatever walk-in there is involved in this or rappelling down or whatever it is, I would only assume that there's awesome mineralogy, like all throughout there. How could there not be?
Oh, yeah. That's
See, but I don't think that's quartz, though, if I recall. I think that might
quartz?
either be calcite or forgot. Yeah, maybe either.
It depends on the hardness of it. Yeah. If they hit it with a hammer and it doesn't move, they hit it with a hammer, it doesn't move. It's quartz. Let's see. Let's see if we have another one. Oh, there we go.
John says they'll only let you in there for 20 minutes, half an hour or so. I think that the oxygen levels are really poor in there just generally, if I recall. Because I read up on this at one time. It's just been a long time. Do you know the name of that right off the top of your head? No, that's no big deal. I'm on the computer already.
Yeah, he says quartz.
Yeah.
It should be a milky quartz, is what it is. I have a whole big rock about this size sitting in my front yard.
I was right. It's selenite gypsum.
Oh.
It's this, which is really cool. See how that's like? See how it has that internal luster like that?
Okay.
Right. What's cool about this is, I don't know if I'll be able to show it to you, but look, I have this. So take a look at this, right? Now look at it with this on top. I don't know.
Oh, nice.
So it's not that it's clear. It's that it actually projects the light like almost fiber optically. So whatever it's on top of, the image of it appears to be at the surface, like a television. They call it like TV stone. But it's it's selenite, which is a form of gypsum, which is a form of calcite. It's same crap that they make sheetrock out of.
I think I have, is it stalactite or something like that? It looks like something like this, but it's real soft. Do Do you know what that is? Maybe I'm saying the wrong name.
Yeah, well, a stalactite is a calcite formation, calcite cave formation. So, you know, when it drips from the ceiling and it condenses over time and solidifies into the cone, but it's calcite. So if you put vinegar on it, it'll sizzle.
Okay, because I got a big rock outside as well. I have quartz and I have this other one, and it's real brittle. And the quartz is super hard. I hit it with a sledgehammer, it didn't move. And then I hit the other one and it shattered. So, yeah. Anyway.
Yeah, I had a piece of quartz that I wanted to bust open real bad, and I took the back of a hatchet to it, figuring, man, the back of this hatchet is like nobody's business. No matter how hard I hit the damn thing, all it did was throw the thing back at me, and I decided before I got hurt, I would stop.
Yeah. Pretty much, yeah. That's what I came
So I didn't have a saw big enough to cut that, you know, like the Dremel wasn't going to do it. Wow.
Look at that.
It's like being inside of like a piece of jewelry, you know?
Yeah.
It's crazy.
That's so cool how it goes. It's like Superman's cave or something. You know what I mean? In that movie.
Mm-hmm.
So awesome.
It is. It's like very geometric too, like polygons everywhere and stuff. I would imagine under like certain lighting conditions that it would be absolutely out of control, like with only certain portions of faces lit and stuff.
Man,
it's very clear.
If I knew one of these was by me, I would try every experiment in the world in there. I mean, why not?
Yeah. I mean, you know, there's so many reasons to do that, but there's so many reasons to do that in any cave, I think, for what it's worth. You know, I just think that being outside of the general noise of the, you know, electrical magnetic interference and stuff, I think that might yield interesting results just generally. It's more of a controlled environment, you know. It's also why they go underground and into mountains and this and that for these projects, I feel like, you know. They say it's for, you know, you think it's for secrecy, but it could also be just to tune out all the signal that's going on.
You know,
make sure.
I used to go into caves, man, and the old combs, not the ones they do today, but the old ones back in the 80s, you'd be able to heat them. And then you put them on a stick and it'd be like a torch. They never wanted to go out, man. The stuff would burn forever. But the new combs, I tried it and they don't work the same. It's not the same stuff. The stuff they used back then was awesome, man. You just go in there, torch it up, go through all the caves, you know what I mean? Check out what's going on. Hopefully you don't run into a bear. But yeah, we didn't know any better.
Yeah, I don't know. I like watch these guys on YouTube that do this cave stuff, and I'm so happy they do, so I don't have to, because I get to see everything that's in there, and I'm like, man, I want no part of any of this. Like, there's a crack this big, and he's like, I'm going in, and I'm like, how's your head even gonna fit? He's sitting there like, you know, whatever, man. To each his own, I suppose.
Hey, Mike, what's going on?
Hey, guys. Not too much. How are you guys?
Good.
Yeah, pretty good.
Good.
We're looking at crystal caves here. Seeing what's
I have a collection of quartz crystal, calcite, Herkimer quartz, a whole bunch of stuff. A friend of mine, he kind of collects that type of quartz. So gave me some samples. I was testing them, resonating it with piezo transducers. And man, did it really amplify the sound. Like it actually put the transducer right on, I guess, the apex of the quartz itself. And I would hit it with, you know, I'd hook it up to the signal generator. And then I get it vibrating. And I just touched the tip of the quartz. And man, you should see it resonate. Like to the point where the crystal will actually start dancing across the table.
Ooh. I got to try that. Okay. So all you did was take the piezo disc, you got it to a certain frequency, and touch the quartz. That's it.
Touch the quartz. I actually rested it right on the quartz itself.
Okay.
And the quartz will start vibrating to the point where it just starts going across the table.
I got to try that.
Definitely.
pretty
That's very
cool.
cool.
Yeah, you have to hit that right frequency with the right amount of power, and as soon as it gets the resonant frequency, boom, it just starts traveling across the table.
Does it light
Awesome.
up at all?
No. If you were to hit it with a hammer on a hard like metal surface, yeah, it will throw sparks.
Right, but the piezo buzzer didn't light it up, huh?
No, I wasn't able to get luminescence out of it. No.
Okay.
You know, if you try the Herkimer diamonds on there, because especially if usually Herkimers are double terminated, that's kind of what makes them super special. I don't know if you have double terminated ones or not, but
The ones
you
I
might
have,
even have a more interesting effect because it has a dual flow.
right, like the ones that I have, they have 4 facets that go to a point.
A single
So
point, yeah.
Yeah, single point. So I got like 4
Alright.
facets going around, 4 flat sides going to the point. And yeah, they resonate really well if you hit that right frequency.
Where I'm probably moving in the next couple of months is only about 15-20 minutes away from Herkimer, New York. So,
nice.
I'd be foolish not to take that ride out every so often to see what I could find, because I mean, some people pull out some honkers, man. Like, I mean,
Yeah,
real deal,
Yeah.
huge double terminated, bigger than the softball pieces of quartz.
my mother has a collection of mica, and it was on my grandparents' old farm they had back in the 1960s. So, anyways, time went on. They sold the farm, or they had the farm, but they weren't really doing anything with it. It was just basically vacant land. And this, I forget which university. It's been so long. It was like eight or 9 years old when she told me. University approached her and asked her if they could do some prospecting on her land. It's more in the northern Ontario region.
Okay.
So they did a survey, and they found a whole whack of like in the ground raw mica that carbon dated like several million years. They found some fossils that dated back over 65 million years. And they gave her some samples, right? So my mother has it stuffed somewhere. I don't know where it is. She won't let me have it. But yeah, mica is something that I would like to actually experiment with, because it's an incredible dielectric, especially like right from the ground. And I remember seeing it. I was about 8 or 9 when I seen it. It's super shiny, and it's in layers. It's really kind of got an interesting texture to it. But yeah, like some of the best capacitors out there right now use mica as a dielectric, especially the AC high voltage ones.
Yeah, well, a lot of mica is very aluminum rich in the first place. And the way that it's mica is formed, it works well as a base if you need an insulator.
Yeah, there's a lot of stuff to experiment. Like just like even Hutchison, he would go outside, randomly pick up whatever rock he could find that he could see a lot of silica in it, and he would smash them down and make his crystal power cells with it.
Yeah. Well, up by you, I mean, there's got to be a lot of interesting stuff just generally, because I mean, you're probably in the Shield, I would assume.
Yeah, we're in the northern Canadian Shield. I'm actually right at the northern end of the Niagara Escarpment. So I got like elevation increase about, I think it's about 600 feet. And it's not too far from where I live. So we call it Rattlesnake Point. So I could actually drive there and go up right up on top of the escarpment.
Nice.
And
nice.
that escarpment goes all the way from where I live all the way to Niagara Falls.
Yeah. I know that the Canadian Shield actually goes into the Adirondack Mountains in New York too. Like,
right. Yeah.
So it's like not close to me but by any means. But I've been up to the Adirondacks more times than I could count, and there's always interesting stuff up there too.
Yeah, I've taken a bus ride from Toronto to New York. So we went through Michigan, went through Syracuse, and then we went through this area. I forget the name of the area. It's just before you get into Manhattan, and it's all mountain range. I'm not sure what mountain.
Yeah, that's the Palisades. Yeah.
Yeah, the Palisades. So we drove right through the Palisades. And I imagine there'd be probably some interesting stuff in that area.
There's not, though, and I'll tell you why. Because the Palisades is not. It's like a volcanic formation, and it's pretty much mostly like basalt and other just regular igneous formation.
Right.
Like that whole entire buildup there is all igneous. So yeah, it just hasn't undergone enough metamorphic processes to have cool mineralization.
Yeah, if anybody gets a chance to take that drive through there, it's actually really nice.
No, it is beautiful over there, for sure it is.
Yeah.
And it's something to see when you go over the bridge from New York to Jersey.
Right.
You're like in the middle of the friggin' city, but then as soon as you're over you could see over the bridge, over the river, and you're like, holy smokes, and it's cliff face. All facing the river, just cliff.
Right.
Hundreds of feet tall. It's very, cool.
I went to Jersey City. Is that anywhere near it, or?
Yeah. I mean, generally, yeah. Like, let's see what.
Yeah, I was right on the coastline, right? I could basically see the Statue of Liberty from Jersey City. They have a national park there, right across. Basically, I guess it's a river that goes through there that separates Jersey from New York or Manhattan area.
Yeah, that'd be the good old Hudson River there.
The Hudson River, yeah.
Yeah.
Sorry, I'm not up to date on the American.
No, you're all good. Please, Well, not many people know about the Palisades in general. That's outside of this area. It's not like a thing, but it's a very unique, geologic formation over here.
Yeah, I've also been through the mountains in California, Hollywood, in the Malibu area. That's a pretty interesting area too. I'm not sure.
Yeah, I've never been over that way, but I've seen pictures, and I mean, yeah, exactly.
Yeah, if you ever go up the mountain, go to the Observatory of California. It's right there on the mountain where the Hollywood sign is, and they have original Tesla coil there, made by him.
Is it really?
Yeah,
very cool.
Check that out.
Yep, I went there and they lit that sucker up. Holy smokes!
Do they light it up all the time, or is it just a special event?
Yeah, no, they do. They do like they'll have tours go through, and I think it's like every hour and a half they'll actually do a live demonstration of the Tesla coil there. And I just caught the tail end of it. I was so mad I missed most of it. But it's surrounded by a 12-foot Faraday cage, because the bolts coming off the damn thing were probably about 5 to 6 feet long.
Nice.
And I think they said it was over 4.5 million electron volts. So,
oh, wow.
That's crazy.
Yeah.
I know that there's some guys that have a huge Tesla coil by me somewhere. And for one of the anniversaries of Wardenclyffe, they brought it over to Wardenclyffe to light up. But it's actually hilarious because it might even be the world's largest Tesla coil, I think they might have said, or something like that. But like you looked at it next to where Wardenclyffe would have been, and you see the size of how the base was, and you're like, yo, this is literally a joke compared to
apparently, that tower. From what I heard when Tesla had his coil set up there at Colorado Springs, his primary was about 40 feet in diameter.
Wow.
Yeah.
40 feet in diameter, his primary. And then he had the secondary coil, which went up about probably a good 20 feet. And then on top of that, he had, I think it was a 12-foot mast on top of that. And that's when he was doing his experiment. So yeah, his was pretty off the charts.
Thing is huge.
It's out of control. Yeah.
Yeah,
Yeah.
well, that's when he did the experiment where he sent the electrical pulse through the Earth and received it at the tower. And when he did it, he had Dollard was saying he had a standing lightning bolt for about 1 minute. Now,
Yeah.
just the thought alone of that is amazing. The
Yeah.
sound probably was unfathomable.
Yeah.
I couldn't even imagine.
Unreal.
You know,
Yeah,
So he had that lit up, had it in resonance with basically he was sending a lot of the current through the ground. And he went 4 miles away and started sticking light bulbs in the ground, and they were all lighting up.
See, I told you.
Yeah. So,
Yep.
you know, the Tesla coil can do it 2 ways, through the air or through the ground. And you know, when you're tapping into the ground and connecting with the telluric currents that are going through the ground, the amplification is, you know, it's unmeasurable, right? So,
Yeah, especially if you hit the water table. Then it just spreads out everywhere.
Right. So when he built Wardenclyffe on Long Island, his grounding was all going into the ocean. Huge, massive copper buses going into the ocean. There is no better ground than that.
Yeah.
You know, I have Lake Ontario within 30 minutes of where I live, and I could use that, you know, Lake Ontario as a ground. Just stick the rod right in the water. So any large body of water will work.
That's what Gerald said. He was going to do an experiment with water and show it to us. So that'd be interesting.
Yeah, it's the best ground you could ever have, really. And, you know, even more so if it's ocean water, it's salt, right? You get better conductivity, right? With fresh water, probably not so good, but if you're, you know, beside the ocean, yeah, you'll probably get some pretty interesting results. And even
he wasn't too far off. He wasn't too far offshore as far as, like, you know, if you're into the, first of all, anywhere here, you're into the water line pretty quick.
Yeah.
Like, you know, we're at sea level. Up where he was in the North Shore. It's a little bit higher elevation, but it's not much. You know, you probably only got to go 10 feet down to hit the water table.
Yeah. I guess the closest to the ocean as I can get is going right up the St. Lawrence Seaway, right up into Quebec. And that's when it starts transitioning over from freshwater to ocean water. Right? And it's kind of interesting. They've had quite a few sightings of great white sharks going up the St. Lawrence Seaway looking for food. What's a great white shark doing in fresh water? They're evolving.
Sharks are weird like that.
Yeah.
Sharks are so weird like that.
Even bull sharks have been known to go up 250 kilometers up the Mississippi River in fresh water.
Oh, yeah. Yeah.
Right? They're being spotted all the way at 250 kilometers right up the Mississippi. I was watching
in Louisiana, there was a big issue after Katrina, you know, where all the floodwaters, all the sharks went into lakes, got landlocked when the waters receded.
You got trapped.
And then now you had lakes with sharks in them, and guess what? They weren't going anywhere.
Yeah. No, they're taking over.
Yeah, so, you know, you go to the lake with your friend, you're like, oh, whatever, and it turns into, like, you know, like something you can make a movie out of, you know. Because the sharks that were going in there, they weren't like the nice kind that you scuba dive with. They were like bull sharks.
No, they're bull sharks. They're man eaters.
Yeah.
See, we have a problem right now in the Great Lakes. We have the Chinese carp starting to destroy some of the Great Lakes. Lake Erie, Lake Superior, Lake Huron, these Chinese carp, and they're quite large fish. And we're thinking about actually bringing in a stock of blue sharks and drop them in the lake to try to get rid of the Chinese carp.
Blue sharks,
The carp are the ones when you drive your boat by, they come flying out of the water at you.
Yeah, probably. Yeah,
I saw that.
You know, I know that saltwater fish have a much better survival rate in fresh water than the vice versa. If you put a freshwater fish in salt water, they're done. But the vice, you know, like if there's an acclimation point, my understanding is that, you know, the survival rate goes way up compared to if they were just taken from saltwater and dumped in. So when when it's a flood condition and they're swimming in and there's an acclimation, and then, you know, that whole, like, you could have all sorts of weird stuff that goes on. But blue sharks are crazy cool. Like, they're big, friggin' pointy, fast sharks.
Yeah, they're fast. And you know, like the Chinese carp is such a big problem. They consider them an invasive species, and they're wrecking our waters. And they've been trying to figure out how the heck these Chinese carp are getting into our you know, freshwater system, right? So that was one proposal. I don't know if they're actually going to go through with that. You know, like you said, as soon as you got them in there, they're in there for good, right? Now you control it all.
Always a bigger predator out there eating things up. That's usually how you do it. Either that,
it's crazy to think that, man. Like, I couldn't imagine that going over well in a council meeting. I mean, I know I don't mean to say only a blue shark because it's a substantial shark.
Well,
you know, but
the interesting about sharks is their neural network is extremely sensitive in water to electrical stimulus.
Mm-hmm.
So I wonder if you could do an experiment and actually.
You beat me to the punch on it, Mike. Thank you.
What's that?
So you beat me to the punch on it. That was like what was been going through my head ever since I heard shark. I was like, oh, you mean those things that pick up a heartbeat from like a mile away?
Yep. Yeah. See, I kind of started here because I wanted to segue into this. But it would be interesting to make an experiment. If you wanted to lead those sharks out of the water, you create a probe in the water and just let them follow the signal, because you know they're going to home in on it, right? So you would make the signal sound like an animal in distress, right? So you would come up with that kind of waveform. The shark would pick it up, right?
Yeah.
And will eventually try to track it down. So that may be one way of luring them out.
Yeah, you know, sharks get beached all the time, but most of the time it's incidental. They come in too close to the shore, a wave ends up washing them in, and it's an incidental thing. There's only very few sharks that will follow its prey onto a beach. Now, a great white shark is one of them. A great white will. A mako, they're pelagic. You know, they live in deep waters. It's not going to happen. A blue shark is also a pelagic shark, but at the same time, you know, they can be closer to the coast, like a great white, because great whites, they love the coast. I don't understand why they're such a big predator, but they love the coast.
Yeah, and they're swimming up the St. Lawrence Seaway now quite a bit. They're actually being, you know, spotted quite often now. So,
well, is there a lot of seals up that way?
Good question. I don't know if it's maybe because of lack of food along the coast that they're traveling up the St. Lawrence Seaway. I'm not sure.
Sometimes with them, it's not a lack of food; it's an abundance of food. You know, they're very, very greedy predators. You know, I used to do a lot of shark fishing, so it's, you know,
right.
They're very greedy predators. Like, they'll eat a seal and then eat another seal. So, like, if there's an abundance of seals, they're going to go where it's abundant, and they have to do as little as possible because they like to be fat.
Yeah. Do you think they would actually do it like almost like for fun? Do you think they actually enjoy hunting, or is it just a pure instinct to hunt?
No, I don't think I don't think sharks have much going on, man.
Yeah, they're just programmed that way, right?
Yeah, no, like, you know, you could look at the actions of a shark, you could look at just the expression of a shark, and so there's some types of fish and stuff that react to stimuli in a more intelligent fashion. so to speak. But sharks, I've never seen a one that has it.
Right.
They're all
Yeah,
just swimming. They're swimming teeth.
They have whales out here. You know what I mean, that'll swim with you and stuff like that. So a little bit more of an intelligent design than a shark.
Yeah, I just find it fascinating because their neural network is so electrified. Their navigational system, they know where they are. It's like they got a built-in compass.
Yeah.
You want to talk
I
about
guess
something
I'll-
interesting that lives in the sea, man? Mantis shrimp. They hit so hard they cavitate. They create a cavitation bubble under the water.
Yes, I've seen that. Yeah, you're right. I've seen that. Where did I see that on? I know exactly what you're talking about. That's really cool. It's like,
And
an
they're very
ultrasonic
cool looking. I've seen them in
shockwave.
person, like at the aquarium. You know,
Mhm,
but
yeah, but they create like an ultrasonic shockwave when they do their snap. Yeah, it's really interesting.
yeah, they literally, whatever mechanism they have is just so fast and severe that it literally breaks a void in the water.
Right. Yeah, like a cavitation,
Wild.
like you're saying.
Yeah,
I've seen
Wild.
videos of that. It's pretty amazing what they can do.
yeah. Like, I just wonder if I kind of wonder, is like a crack of the see, I guess to precurse this, whenever I talk about energy, you know, I know you guys know, but I kind of get the vibe like people still think I say energy and mean like even current or anything like that. Whenever I say energy, I'm talking about the whole spectrum of it. I'm talking about acoustic sound. I'm talking about vibrate, anything that creates a waveform. Okay, because in my opinion, it's all a constituent of the same. That's just been my theory. Sticking with it. So I'm just thinking about how analogous it might be when you think about like the crack of a whip.
Yeah.
Okay.
Yeah.
And what that the little thread at the end, like the little cracker, does when it hits supersonic speed and ultimately backtracks, creating probably
A vortex.
what would be a cavitation bubble if it wasn't for, but the only difference is that because it's an atmosphere, it's harder to create cavitation in atmosphere than it would be in water because of the density.
Yeah.
When you have a high density, you have a higher chance of being able to push that density to the side for a little bit. When it's loose and it's thinner, it's more difficult because it collapses sooner. That's all I'm thinking, you know. So, because realistically,
like
creating that void that is the magic right there. You create a void in space, you got the goods.
Yeah.
That's the goods.
Well, the thing is, you know, these animals have, you know, evolved over millions and millions of years, right? You know, you want a physics lesson, just, you know, watch that shrimp. It's pretty incredible what that thing does.
It's amazing. Yeah.
And now that, you know, we have, you know, high motion or high speed cameras, we can actually pick it up and actually get a good visual. I think it's creating a plasmoid cavitation. And yeah.
I mean, it has to, because with that cavitation bubble comes the immediate collapse of that cavitation bubble. And whatever's created in the expansion and contraction simply cannot cease to exist.
Yeah. I wonder how much energy. I wonder if they could actually put a probe there and see if there's any electrical current being created when it does that flick. I wonder.
Well, so that's the thing about it, is that it's not the strike and the impact from the strike
it's the
that does it. It's the shock wave from that cavitation bubble.
Right.
It is that cavitation bubble. It instantaneously knocks unconscious or kills whatever it's aimed at.
Yeah. Yeah, it's incredible. Wow.
Yeah.
Guys, I have to cut it short today. I gotta drop my daughter. She got a sleepover today, and then I'm taking the wife out for dinner. So,
Well,
thanks
thank you
for
for
dropping in, Mike.
by. The show last night was awesome, by the way.
Yeah, man.
Yeah, it was a good show. It was a good show. Yeah, enjoyed it.
I had a good time
thanks
with
a lot,
that, breaking chops and such.
Yeah.
Yeah. All right, guys. Take care.
Have a great day, Mike.
Okay, take care. Bye.
Oh man, we should just do a special on Shark Week. You know what I mean?
I think that, yeah, man. Like I said, this stuff, it all ties together in the weirdest ways, you know? It does, because like it's never an abrupt, like, how did we get here or something? It all found its way, you know?
Oh yeah. No, it all circles back, that's for sure.
Yeah.
All right,
John
Joe.
Gray,
Been...
real quick,
Go
he said, good visual picture, thank you, you're welcome. And water to air. So, and I said this previously, so it's good that you brought that up. Anytime I'm thinking about any of the wave concepts or pressure differential concepts or anything like that, I always think water, because it's the easiest to visualize. That's for me, you know. Okay. So, you know, in a case like that, it's super hard to understand in your head how you would create a void in air when you can't see air, and you can't see a pressure differential in air unless if there's something else in air to show that pressure differential. But in water, you can, because you could create a void in water that would appear to us to be a bubble, which we would assume is filled with air, but it's not. It's just simply a void, which is the craziest part. So once you realize that, and then you take the water and then you move it up into the atmosphere or beyond, then you kind of get the understanding of, well, what's going on here. I don't know. It's always the way I like to think about it. So
very cool. Let's say hi to Sean real quick. What's up, Sean?
Yeah, thanks, Sean. You made it into my song too. Everybody was in my song. Mike was in my song. I don't think I forgot too many people.
Yeah, I'm gonna play that one more time. Let me do that real quick before we take off for the day. And I'll drop your site back in there again. So.
Thank you. I appreciate that as always.
Okay, there we go. Pull it up.
Sean, that's really cool, man. Inside, like you live physically in an extinct volcano. In. That's cool.
Here we go.
In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe is all fuel. It takes the talent of the craftsman, it takes the mind of the fool to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bill was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie making power for days. Don't listen to a word that the straight no says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plausible to mile long. Sheila on the video making tones jump the prongs. Burning breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bills. Cook.
And there you go. You've all been represented, I hope.
So it's time to spend your Saturday with the dope and old man Builds. Man builds. Yeah, the old man builds. Yeah, the old man builds. And though the old man builds what is running through his head, Gerald probably got it hiding under his bed. Benny ups to Annie making power for days. Don't listen to a word that the straight no says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plausibles a mile long. Sheila on the video making tones jump the prongs. Burning breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Builds. Cook. Yeah, the old man Builds.
Oh man, that's such a cool song. Thank you for that, man. That's awesome.
Yeah,
That's
anytime.
that's
You know, it was fun
that's
to do. You know, so
the way to rock it out, man. I like that.
yeah. So keep on building what's in your head, brother.
Yeah, right on.
And
All right,
Gerald,
Joe,
I'm
you got
on
anything going on or anything like that? I went ahead and threw your site in the chat so everybody could go over and subscribe to you and everything.
Yeah, thank you. As far as like channel update stuff goes, right now, again, I'm still trying to get my move on and get that together. And as soon as you know, I'm done relocating, I'm gonna start producing some, you know, more exclusive, you know, probably bi-weekly content. So, you know, it probably wouldn't be all too much different than this, just not live, you know, and edited, and plus I'm a total idiot, so you know, expect that.
Oh, is it that?
Yeah.
Right
If
on,
you want
guys.
stick figures of cursing Jesus, I got it. No problem.
All right, guys. Tomorrow I'm going to do a open mic. So you want to come on and say hi, ask me questions, or ask questions about whatever we're doing, stuff like that, feel free. Probably 10 a.m. is when we're going to start. And then we'll see where it goes from there. Whatever the day is, it is. You know what I mean? But other than that, guys, have a great day. And thank you for watching us today.
Peace and love.